patient. Okay, Marco Potenziani, the video should be ready to be put in the web page, and then I start recording.
Okay, thanks, Marco.
Richard Pook, are you here for the fourth paper? Should I move you to the panelist? Just raise your hand in case. Do we have someone else among the spectators that need to be moved as panelist? Just raise your hand in case, and we will move you. Speak now or forever be silent. I believe we have spectators and we have most of our members online. So
Okay,
I believe we can.
Is perhaps Effie Locke, perhaps she should be a panelist, or do we already have a
Yes.
panelist for, yes.
Yeah, if someone else of the spectator then need to just tell me and I can pop them in. To make co-host. Yeah, co-host. Yes. Good afternoon, everyone. Let's start this afternoon session. This is the second paper session. We have 4 papers to present, and I leave the floor to Vincent Marchetti, which will be the chair of this session. Thank you for coming and enjoy the conference.
Okay. Now, should I do something so I appear large on the screen? Yeah. I'll just talk. I'm the little head. Good afternoon, good morning for those of us in the States. I'm Vince Marchetti. It's my pleasure to serve as host or chair of this session. We'll be hearing presentations and discussing 4 papers that all have the theme of improving the quality of our virtual experience. And as we all know, across the globe, in the last 2 years or so, we've been forced to address our dreams of doing things remotely and virtually because all of a sudden we had to. So we have a paper on assessing the quality of virtual experience for education at the college level in some courses in agriculture. Our second paper is developing methods to evaluate how different browsers or different rendering environments might visualize the same underlying model and figuring out ways that we can do some quality control so every user gets the comparable experience and that content authors can be confident that their content will be visible in a certain way. We have a paper on improving latency they have developed some algorithms for loading assets in a way which improves the virtual experience. And then also some recent developments in extending the X3D standard to give access to better audio, I guess, the audio visualization or rendering of audio in a 3D virtual environment. Our first paper is, I believe the presenter in the pre-recorded session is Dr. Nicholas Paulus. The title of the paper is X3D Field Trips for Remote Learning. And it's very interesting, but the one sentence from the paper that jumped out at me was, the operator hid behind trees. So I hope that either in the remote session, Nicholas explains that, or we can discuss it in the question and answer. So if we can start the recording, please.
Hello, Web3D. Welcome. My name is Nicholas Paulus. I'm happy to have you here in the Visionarium Lab at Virginia Tech to present our paper called X3D Field Trips for Remote Learning. So we're really excited and obviously thrilled about Web3D technologies can last. And if you speak web, we're ready for you. We can integrate and consume all that great data and services that are out there published in the standard web stack. So what are we going to talk about today? Well, I want to do a quick, very quick review of the learning applications that we've been inspired by and that we've worked on in Web3D over the years. Then talk about the disciplines and the domains that we worked with for this paper and the scope of this paper and the kind of lessons that they connect to in terms of their pedagogical purpose and the reason why we're able to use Web3D technologies in the educational setting, undergraduates, professionals, graduates, for example. Along the way, we've seen all kinds of design challenges. That's really what this paper is about, how we address them and the kinds of feedback that we received. There's obviously a lot of potential and great work to do. So let's see where we can go on our field trips here. Well, virtual experiences and learning has been going on a long time. We started to see some real momentum build in the natural sciences and geography and hydrology, for example, as more and more of our colleagues, became equipped with these nice capture platforms, 360-degree cameras, LiDAR, drones, etc. And we started to publish that and put those into, again, educational contexts for the students at Virginia Tech. We also know that it's supposed to be fun, and with open-ended agency, users can really engage with their field trips and the place that they're going to, even if it's virtual. 3D is a great platform to help make sure that we have common reference points and grounding, right? So if we're talking about a new building in civil engineering, being able to look at the scale and walk through it from all kinds of perspectives, again, is really powerful. And we've used immersive and WEB3D design for some award-winning sorts of projects that you can see there on the wing. It has a video link. So we know that there's no substitute for going on the field trip, right? We all want to go there for real, but there's a lot of reasons sometimes that we can't, for time or money. And so virtual experiences can provide, reasonable, compelling surrogates for that physical field trip. But even if you are able to go, your time might be limited. So you want to make sure that you spend your time on site most efficiently, right? So in a certain way, also these virtual field trips can prime us for spending our time more wisely when we do actually get to the location. It's super important, right, in all of these examples and all the other ones in the literature, that it's a real partnership and a design dialogue where you're talking with the instructor, talking about the standards of learning that it has to connect to, the concept inventory, right, what sort of activities they might do in the traditional educational setting, and then how can we translate those into a virtual setting. So we kind of collected in this paper a series of research projects as we're trying to understand the usability and deployment of these on a land grant scale, a mission that includes graduates, undergraduates, professionals coming to Virginia Tech to learn about land management practices and all sorts of things, as we'll see, including environment design. So a little breakdown there. And as we go through these, I'm just going to point out the main lessons. And of course, you've read the paper. But in any of these places that we want to go, right, we can often count on a few common elements, right? And we know we're going to have a map of a place. Maybe we have some local data, like a sensor that was in the stream for the last 10 years, and we want to go and look at that sensor data. We might have 3D objects like a bridge or a sculpture or a shrub, right, that are set in a location and have potency in terms of the pedagogical value, right? We want to portray them, we want to show them and use them as lessons. So 3D objects, and then now we have cameras that are capturing 3D spherical video and imagery, and this gives you a photorealistic sense of place, right? So what we want to talk about mostly in this paper is sort of the three kind of flavors of challenges that we encountered, and these are probably going to apply to any future sorts of virtual field trips that you might take on the web, immersive or desktop or by phone. First one is, how do we put the stuff together, the scene composition? Oftentimes we're processing different data sources. We've got to merge them, register them, etc. So there's a few sort of technical and engineering challenges there. The second thing is the 3D user interface. And this is an interaction design kind of challenge where, depending on the activity and the pedagogical purpose, you might want to change a navigation mode, right? For example. And this becomes a problem of interaction design. And as these virtual field trips become richer and you start to build more data into them, sensors or tables and other kinds of data, you're trying to think about how you lay that out on the screen or in the immersive environment. This is information-rich kind of layouts. So the three flavors of our design challenges. All right, well, we get equirectangular projections from a lot of these cameras. They come in now, more and more resolution. And here, actually, you can see behind me an example of one of our captures over at Strubles Creek on our Stream Lab. And we're just downstream from campus, and where we have several monitoring bridges set up. And we have a whole number of interesting things that you might want to see if you come to Strubles Creek, right? We have the sampling bridges. Maybe we've scanned those with a terrestrial or a drone-based or a handheld kind of LiDAR. So we've got objects in places, and we want to show them in context. So we're trying to integrate these field trips, obviously, with more of an overview and a survey kind of knowledge of the place, okay? We've got viewpoints in every photosphere, but if you go inside of photosphere and you're used to 3D graphics, you'll probably notice that your text comes out rendering backwards, right? So we know we have to flip these equirectangulars. Here's just a quick example of kind of what I'm talking about, right? We've got locations here on a map where we've gone out to the field. We've captured photospheres and 3D objects. 3D objects including Professor Mansell here, who's sampling the ramps patch with his plant shoe application, entering GPS and natural observation data. Ramps are delicious, by the way. They're a relative of the onion family that we enjoy very much in the springtime here in Appalachia. So we've been able to contextualize now this activity in the place at McDaniel's Nut Grove, for example. Now we've been able to bring together over the years, based on this idea, a lot of different kinds of content and for different purposes. So I'm just going to show quickly a few of these virtual site visits that we've done. So one of them is with the Appalachian Trail Conservancy, long trail, limited amount of time, but they're talking about surveying from view sheds of the Appalachian Trail, natural, cultural sites of historic significance, trying to understand what parts of the landscape to preserve if you're walking along the trail. So we can take them to all the sites along the trail in an afternoon. And that's a lot easier than hoofing up the backpack and the boots. We've also used it in graduate education, design activities. Okay, I'll talk about the project where we had graduate students designing with USDA software, image software, their planting recommendations for specific sites. And they were able to design, share, and then present those designs through a virtual field trip. And then finally, we hosted an agroforestry conference here in Blacksburg. And I'll share with you a few images and examples of how we were able to take the attendees to the conference, which was before COVID and here physically in Blacksburg, take them to many sites in a half a day, and thus, give them extra experiences and also prime them for the sites that they were going to see in real life. Okay, so here's a little picture of the Appalachian Trail Conservancy crew here in the Visionarium. We're looking at it in stereo in this case, and they're looking across the valley at where the trail is going on the way to Angel's Rest, which is an iconic location right outside of Blacksburg, just a little northwest. Here's an image. This is also in a video from the lab in Vimeo if you want to watch it, but Professor Munsell and his students, and you can see in the background, they've actually planted a whole series of different species in various locations on a certain hillside based on the spherical imagery that they acquired in the field. Here's another example. This is from the conference tutorial. And actually, I can bring this up. I think if I hit that and then I hit this, we'll load up the example here with that we use in the forest farming, right? We've got several sites we want to visit, right, back there. Some of them are talking about golden seal, some about ginseng, some about black cohosh, some are hardwoods, some are mixed woods. And basically, we just want to browse the environment right, by hopping around different viewpoints. And we're going to always make sure that we go outside the sphere and then back into one. So here we are in one of those examples. And I might be pointing out to you some things about the slope and the density of the planting. Maybe it's something about the canopy or the ground forest floor, what kind of soil is here, right? And maybe we want to go to the next location, and I'll just hop to the next viewpoint, right? And on a desktop, this would just be page up and page down, right? Okay, so being able to take our conference attendees to several places would have taken 2 days to drive to them all, but in an afternoon, we're able to scaffold and create lessons about all of these special locations and the considerations for management. And here's just a picture of an attendee in the exhibit hall at the conference going to the ramps patch with Dr. Munsell. And this was actually the ramps patches in New York. It's probably 10 hours away from the location. Okay. So we had some initial successes, some real compelling experiences that were focused, right, on different disciplines and on specific pedagogical purposes, right? So the next kind of design challenge that we had to come across was about the 3D user interface, right? So I'm here in immersive cave. I've got all kinds of 27 million pixels around me to project and look around. I can use 6 degrees of freedom navigation, right, with my wand device. And that seems pretty natural, but if I'm on a desktop or on a phone, right, I might have to experience the same content, but just with in a different way. So I'm going to talk about some of the challenges we face just based on the standard kind of the standard X3D deployment. Okay. So we worked with Katie Meany. She's one of our co-authors here and a professor in the School of Visual Arts. And one of her undergraduate classes and one of her specialties is environment and exhibit design, right? So you think about public sculptures, you think about museums. How does the content, the user, the context all communicate, right, to make an experience? And so she was really interested in the Bauhaus movement and Herbert Bayer's sculpture called the Chromatic Gate. And so for one of her projects with her students, one of the units in the class, talking about environment and context, was to take the chromatic gate and put it in different places. So in different contexts and locations. And we were able to do that with a virtual field trip and of course, easily with X3D. But some of the things that we came across, right, were that if you're putting the photosphere around the object, where's the ground, right? It's a sphere. So essentially we had to create an invisible floor in order for our walk mode to function as expected. And you can see this in the video and also in the web version. Invisible floor, the viewpoint starts at the center of the sphere, 1.6 meters or whatever your avatar size is. And you explore and navigate the environment in walking. So I'm just going to step away for a second and load that up here. Okay. So yeah. So here we are at the Bauhaus School. This image is copyright Dirk Blundell. But you can tell what we're doing. We've put our avatar, our virtual camera, right, on the ground. So now I can walk, and I can literally walk through the chromatic gate. Let's see if I can get in there from behind. Right, but now I'm observing, I'm experiencing this sculpture at real life scale, and it also has its context. And we can take this to Mars, we can take it to the beach, we can take it all kinds of places. It's actually installed on the West Coast in California somewhere. You can go visit it. Herbert Bayer's chromatic gate. So one of the design challenges around 3D user interfaces was, navigation and trying to make sure that the user saw and experienced the world as a walker, from ground level, as they would as a human. Okay, so navigation mode, a little bit more about that. Fly is awkward. We can tilt and roll. It doesn't quite seem right when you're inside the sphere, outside the sphere. Walk works more like we expect it to, like you're on the ground level, you're looking around, you're on an invisible floor. And you know, the default in X3D, the examine mode, is kind of the opposite of what we want, because really what we just want to do is sort of pivot our head from the inside out rather from the outside in, which is what examine does. So we looked at the turntable mode, which is an experimental mode in XFreedom. It's not in the spec, but it does have some nice features, right? There's no roll, and it's in the web browser. So if we sort of dug into this, we started to think about, okay, well, you know, these remote field trips work pretty well if you're using certain kinds of metaphors to map your 6 degrees of freedom of your camera control. Well, on a desktop, you know, it was that the default implementation kind of moved the camera in the direction that you were dragging, right? So it's sort of like camera centric. But the instructors and the folks who were going to deliver this sort of realized that, sort of said, hey, you know, is that right? It doesn't feel quite right to me. And they were working on the metaphor more of like a touch screen where I might have the photosphere here. And when I drag, I'm actually dragging the sphere, right? Not the camera. I'm not moving the camera. So that was the main difference, right? We just basically had to reverse the drag vector. And so we thought that's a good idea. You know, let's try it. We piloted it out with a bunch of the stakeholders, and it was overwhelming that they preferred the drag metaphor to work inside the photospheres. And so that's what we deployed with the class. All right, the USDA issues certificates for our silviculture and forest management programs. These are people from USDA or BLM or indigenous nations. Every year we graduate a cohort of 30 of these people who are now trained and can make decisions about how we manage our forest land, right? So there's going to come up with a variety of challenges in their career, different regions, different kinds of species, right? And so the certification is meant to kind of give them the tools, theoretical and otherwise, for best management practices, land management. And so we decided to build, when COVID came, we said, we've got to pivot, still need these people in the field. Let's get the certification done with virtual field trips. Okay, and this is an opportunity. So we know we have these places, they're all well measured. We send out Dr. Munsell, and we enlist his students and his colleagues, his team, to annotate these trees with property ends that are all basically displayed in different layouts with HTML, right? Divs and Z orders and so on. So we're seeing overview of a map. We're seeing the photosphere of our location. We're seeing details of each forest plot. So here's kind of like what that overview looks like, right? It's kind of pretty much the same that I've got on the phone, right? And if you go to that URL, we've used the inverted turntable, the pull and drag metaphor in these environments. And then if you can pull out different, maximize different kinds of information displays about those trees, right? For example, their size, their species, age, things like that, where they live in the overall site in terms of this plot. So as you're designing a land management program for this site, you're thinking about all these different plots and you're thinking about all these different trees and you're trying to make a good recommendation. So as you can see, a lot of design challenges and obviously logistical too, but once we can put a URL up, a URL is the place that you go for this field trip, right? It's another address. It's just a virtual one. So the art students gave us a lot of qualitative feedback, probably the most, we would categorize them into a couple themes, right? Affinity analysis. Most of them were really changed their sense of scale in their discussion. When they're talking about a sculpture environment, looking at a static picture is very different from having intentionality to explore and look at the object from different viewpoints, right? And understand it in relation to yourself, your scale. They were excited about the novelty of, having classwork that was in VR, and that was neat. But that agency, that they could do this virtual field trip, kind of go off on their own to do certain things was really valuable to them. So those are a couple things that showed up in the School of Visual Arts class where we deployed these virtual field trips. COVID came, we did the NASP certification program with professional foresters, right? So these are people who are already working for the USDA or BLM or the Indigenous Nations managing lands. And usually they take a week and a half, 2 weeks, they travel to a location, they're focused in on these activities. It's an intensive program, right? Short burst of education. But with COVID, there was a number of challenges, people are still at home. They still have to deal with their kids and the boss and all this sort of stuff. And they've been online all day already. So there were a few challenges, but overall we saw 89, 90% of the respondents really saying like, this was valuable. This was a worthwhile surrogate experience, my virtual field trip. Even if they had come to Blacksburg for this training, they wouldn't have been able to visit the North Woods of Maine, right? A Southern Georgia, pine stand, Northwestern rainforest, right? So they actually got a really well-rounded experience, sort of despite maybe the fidelity and detail that they might be missing. And indeed, some of those subjective comments, a few of our really astute, I think, students, noted some things that we're going to have to work on, which is that, hopping around and teleporting to these different spheres kind of makes it really difficult to integrate kind of the full space in some sort of survey knowledge, some overview, right? So these are the things we're going to work on next. We want to keep on that usability improvement, iterative and progressive. And of course, we're going to be offering these classes on into the future. So we've thought about some different ways of creating better spatial context and spatialization of the information. So having maybe not just one sphere at the middle of the plot, but also looking into the plot from the 4 cardinal directions. So you actually have 5 spheres per plot. Understanding how those plots relate. So maybe instead of, an overview map, we really do get the LiDAR from the location, and you can see the slopes and the angles and some elevation in there as you're moving between the locations, the plots. And the other thing, again, about sort of information-rich integration, we know we can do this better. We make it easier so that if I know that tree 13 is on screen in my photosphere, oh wait, where is that over here? All right. Oh yeah. Well, now the data in the table for number 13 shows up at the top. So we could coordinate some kind of sorting of the data table based on what the user is looking at. That's, I think, would be a valuable feature going forward. So thank you for your attention today. I want to welcome everyone to drop us a line, take us on a field trip to your place, or if you want to collaborate on more kinds of research in this area, how to make these experiences more effective, authentic, usable. We know that it's not just about virtual environments and virtual characters. We need disciplinary experts, and the instructors are what make the field trip, right? Your docent explaining to you real time what you're seeing. This matters, and it helps with retention and all sorts of things. We think that this could scale up a lot more, right? These 360 cameras are out there. So maybe if we work as a community to establish some templates and maybe some simple services, we'll be able to all visit each other a little more readily, even in the times of COVID. The web is wide, and I look forward to visiting your part of it. So thank you very much for your attention. I'm happy to take questions now.
Okay, Nicholas, thank you. And I want to remind people that you can ask questions on either the Zoom chat or the Whova chat. And I know that Nicholas looks like has been answering some questions. I also am cognizant that we started a few minutes late, and we certainly want to hear all the other presentations. So Nicholas, I know from the chat, you've been discussing some of the other sensory inputs. So let me ask if you can briefly sort of address that issue. The issue was brought up of sound, and that might be important because in a little while we'll be hearing about sound rendering. So Nicholas, sound, smell, and touch.
Yeah, thanks. These would certainly create a more immersive or possibly a compelling experience. In our case, right, the cattle fields are right down the hill, so there might not be a very pleasant smell. But yeah, these things do impact presence, and certainly audio would be the easiest one, and being able to have, again, sort of spatial sense of if there's a highway right in a certain direction, that that's reflected also in the rendering of the sound. So I think it's got a lot of potential. As we say, I think one of the best parts of this is that it sort of translates into someone's home, right? It doesn't need this cave to go on the trip, and we can see what kind of consumer devices emerge as well in the next few years. Thanks for that question.
Okay. And I remind people that this Whova application we're using allows you to continue these chats and conversations as well. So perhaps it's appropriate to advance to the next paper. The title is X3D and GLTF Model Differencing for Conversions, Comparison, and Conformance Testing. And so I'll ask if we can start that recording.
Hi. Welcome to our paper on X3D and GLTF model differencing for conversions, comparison, and conformance testing. X3D4 now includes full capabilities for GLTF 2.0 compatibility, providing physically based rendering and lighting techniques. We want to ensure that X3D4 players match exactly to each other and GLTF reference images in every single use case now and in the future. The main point of our paper is to walk through different differencing methods that are useful and helping find out why models look different. There are several different types of differencing techniques that we use. The first is plain text differencing. It allows us to find the differences between two models that are represented by just plain text documents. The second is structured text differencing, such as the differencing between two XML documents. 2D rendering differences is most familiar to most people, where we compare rendered images and use differencing techniques on them. There's conversion differencing, where we look at the same model that's been rendered with a GLTF render and convert it into an X3D rendered model and do a comparison that way. And that's been very useful for helping us identify issues in specification and conformance. 3D differencing looks at how a model's structure may change over time, whether that's the mesh through some reduction or compression techniques may alter the underlying structure. And another type of differencing is in animation, where certain keyframes are selected and then we choose the 2D differencing techniques. So canonicalization is important because in plain text documents and even some of the in some of the structured formats, there's not always consistent ordering between data elements or representation of those data elements. So getting those same peer level sets of information ordered in a way that's consistent helps us do differencing comparisons. So structured text differencing is quite mature. Many folks who write application code use this all the time to understand where there are insertions or deletions and how a particular code base or structure changes over time. And so we've adopted this to do comparison for the structured types of documents, mainly XML-based documents. And a simple visual illustration shows a change in a line, deletion and insertion. Using a color scheme, it makes it very apparent where a certain change occurred, and if that change caused a difference in the object models, then we're able to find out where and ultimately what and why it changed. So in 2D rendering differencing, we can look at sets of things like the particular reflection mode of a surface property and see how those changes to an implementation, a rendering implementation, may cause differencing over time in a set of features. So this multi-textured teapot example is a useful example of that. We use to find where there were additions needed to the X3D specification, and it was helpful for that for us. One thing that we found very helpful is the GLTF 2.0 samples, and we scripted the automation of the conversion of those to X3D, and then we also scripted the rendering of those models for generating comparison images. So the example you see is one in particular that is pretty common in helping shake out where there are differences in the specification or where there are differences in the implementation of the specification. And this sort of use case is the latter, and it makes it apparent when maybe a certain feature isn't implemented yet in a particular X3D renderer. Another type of differencing we found to be helpful is looking at the actual changes to the 3D shape over time. This 3D differencing is useful in showing where there were changes in volume, both insertions or deletions to a particular model. The other type of differencing is video differencing or animation differencing, where we have multiple keyframes within a sequence, and each has maybe a different model state, a lighting state, changes in camera position and orientation, and we perform, in essence, a 2D comparison at those individual renderings for each individual frame or a subset of the individual frames within a given sequence. We come to a common theme in going through this differencing work, and the common theme is that these tests are repeatable. They can help ensure consistency. They're contained in a way that's very similar to unit testing perspective, and we felt that if we share these tests in GLTF sample models and scripts out there, that we can help improve the testability and help address the problem of consistency between the renderers and the viewers. So the major conclusions of our work are that yes, we've found these differencing methods, and yes, they've helped us shake out a common recurring set of reasons why. So the first is, yay, we're able to test GLTF 2.0 and X3D 4.0 and able to make those representations with a subset of models, the GLTF 2.0 sample models. And then we know that most of the differences are caused by not having defaults in a particular scene, or differences in default lighting settings and things like that. They're not necessarily conversion errors, although we did find and update the X3D specification, so it has been quite helpful. So there are a number of areas that we came across for further work. The first is in the viewers and converters area. There are some issues with correctness that we identified that could be worked on and improved. The implementation of the spec, just various features that need to be built out. And then looking at sort of the spec itself in terms of color mode and making sure things are kind of fully correct there. On the efficiency side, there's work that's needed for binary encoding, as well as tools and implementations to bring about a more efficient representation, a binary representation of the models. Well, we're happy to help and to join the party to make Web3D graphics better. We want to say thank you to the folks who have built GLTF 2.0 samples repository. That repository is very detailed and covering many of the specification topics that are useful when doing differencing testing. We feel that we can add more open test examples that will be even better. We think it's helpful to continue to convert GLTF to X3D, not only for differencing comparison, but for generating samples as well. We feel we can be a good partner in a continued dialogue to share the best ways to convert GLTF to X3D, and we hope that we can liaison and work to match capabilities and learn from each other. We're very thankful that the WEB3D Consortium and the Kronos organization have entered into a formal agreement to ensure that compatibility and correctness continue for these complementary standards. We'd also like to mention that none of this work would be possible without the deep technical expertise and sustained efforts of Michalis Cambarellis. We're very grateful for his continuing work with both X3D and GLTF. We are continuing to work on this effort. Please send us bug reports. Thank you.
Okay, thank you, Rick. I'm looking to see. Okay, I'll ask. Perhaps Marco can promote Dr. Brutzman to being a panelist, but Rick is also able to answer questions. I invite the attendees to ask questions through the chat. Rick, let me start with a question. I don't want to make it too broad, but when you do this comparison, are you strictly operating at the sense of the entire scene? And what I'm thinking about is effects where, and we remember the blue dress, gold dress controversy from a few years ago, where the appearance of things sometimes depends on the context in which they appear. Is this a factor in the kind of differencing that you studied?
The samples, if you guys can hear me okay, sir, the samples are typically more granular than that. There normally is a default scene setting that takes place in terms of the initial viewpoint and lighting, things like that. But it, for the most part, for the current samples, there's just single viewpoint that's consistent between the formats and the ultimate end rendered state, at least for the 2D comparison. And in terms of geometry and text-based comparison, those things can operate down at the individual object level, sort of irrespective of orientation. Sure.
Okay.
Yeah, and that's correct. And Vince, in support of your question, I think we're fortunate in that the GLTF folks have generated what they call reference images and corresponding to the models. So we are specifically not trying to deal with every interaction or unforeseen possibility, but rather strictly focused on, well, if this is what it says, what does it look like? And we ask that question twice. We say, if this is what the GLTF model is, what does it look like when the X3D player loads the GLTF model? And then we ask it again to say, if this is what the GLTF model is, and we convert it into X3D4 nodes, matching the correspondences that Michalis Cambarellis has done, then does it look the same? So it's all about quality assurance. It's about consistency. It's about, can the rendering look the same when we mix and match X3D so that with GLTF, so that we can say, yes, we have good representations. And frankly, I think every time we come up with edge cases, like maybe the one you mentioned, oh, we're learning something. We're learning something. Yeah. Do we have all of the default parameters set? Is there something that's been overlooked? Is there something in our native rendering that is not matched to our X3D adaptation of that same rendering?
Okay. So I'm looking to see, because if there are any other comments or questions, we do have a little bit of time for an additional discussion. I don't see anybody's hand up. So let me continue. Rick, you mentioned that you attribute the differences at some level, you attribute that to lighting. As a little bit of an insider, I know that, and you mentioned Michaela spent a lot of time understanding the equations of physically based rendering. Does your work indicate that similar work has to be done to have compatible lighting across these? Well, we're talking about two standards, X3D or GLTF. Is lighting the next challenge for this work?
Honestly, I'm not sure. I'm sure it's definitely challenging. But in terms of the specifics of each implementation, that this sort of work will kind of point in a direction of maybe where the problem is, and then obviously there's a much deeper type of analysis that happens, and to kind of work out those consistency issues. So having the scripted, having it repeatable, so that if you're doing an implementation or doing a change and you commit that and want to just make sure that everything is still working, or that you didn't throw up any red flags in the commit and things like that. This will be helpful. But you're right. There's a far deeper body of work that's happening regarding the math and data implementations.
Yeah, that's right. And I must say, Vince, I shared your concern about whether lighting is a big issue or not. And oh, look, there's lighting. Because I think as we were first looking at the GLTF examples, they didn't always have lights defined, or they look different. There are some pretty infamous slides over the years where you would see 9 different Anakin Skywalker helmets. And, the moral of the slide would be, oh, look, everybody can do GLTF. Then you look at the images and no two are alike. And, so what's that about? Well, I suspect that the root cause there might have been maybe not lighting differences, but rather no lights defined in the scene, and people were doing their own lights. And of course, that greatly changes what things look like. So as we go through the examples, and we've only done 12 maybe out of 75 current examples up there. As we go through and compare the original GLTF with the loading of it, as we go and compare the original GLTF with the conversion, and then the rendering in native X3D nodes, we should see the same thing. If we don't, it's lighting is good cause, probable cause. Another secondary, quite related, is whether lights have all of their default parameters defined. And we are finding now that just about everything does have default parameters defined. So consistency appears to be possible, is the short answer. And working through every example diligently, putting it online, making it available for X3D players to do the right thing, will let us really put our fingers on what is the right thing. Is the example a good definition of the GLTF spec? Is the X3D mapping of that a good correspondence, or have we overlooked something?
Thank you. Okay, so I think we should soon move on to the next paper. Don, I will refer you to the message from Carol. Her group with an IEEE is very interested in things like such as fabrics and more organic materials, and which is another challenge. But let's move on to the third paper of our session, the visibility aware web-based virtual reality. And I believe that Carter Slocum is presenting and is available to answer questions. So we can proceed.
Hi,
Thank
WEB3D.
you.
Welcome to the presentation on VIA, Visibility Aware Web-Based Virtual Reality. I'm Carter Slocum. I'll be giving the presentation. I'm a 4th-year PhD student at the University of California, Riverside, and I worked on this paper with Jingwen Huang, the 2nd-year undergrad, and Professor Jesse Chen, both of our advisors. So to overview the presentation, we're going to quickly cover some background information in order to understand VIA. Then we will go into the main problem that VIA solves, the causes, and how we came about the solutions. We will then do a quick demo of VIA in action, and then we will go into the experiments we ran in order to evaluate VIA, and those results quickly finish with a Q&A session. So to start with the background, VIA came about as an idea when poking around the WebXR framework. This is where we get the web-based virtual reality component of the presentation. WebXR is a framework built on top of WEB3D, which is designed to enable VR and AR on the web. WebXR uses a technology known as the GLTF format in order to transfer the graphics information over the web. The GLTF is a JSON-like file object which contains metadata about the geometry and the textures of a scene. The geometry is typically stored in a .bin file along with other information like animation, and the textures are mostly stored in really common image formats like PNG and JPEG. So the main problem that we encountered when working with WebXR is incredibly long loading times on mobile devices like phones or headsets. These loading times could take anywhere from 30 seconds to multiple minutes on incredibly slow networks. The download sequence of these objects is similar to how you would request images and JavaScript and text on a normal web browser, but in this case it's more complicated, much larger because they are full 3D scenes. The main causes that we could find for this problem are the first being that all the geometry and animation data are stored in one large .binary file. In some cases, this binary file can be larger than all other files requested by the website. And this must be downloaded before any objects can be rendered in the headset or on the web browser. Typically just one of these and many image files. The image files can be bigger than the binary, but in some cases the binary is so monolithic it dwarfs them. The second cause that we could find is the fact that all of these images are requested in arbitrary order, typically whatever order is decided by the 3D modeling software that generates the GLTF in the first place. So for example, here we have a user who's standing on a balcony of a shack looking at a satellite dish on top of a mobile home next to them. The roof above the shack, which is not visible to the user, is requested about 6th over all of the 50 objects that could be requested, and the satellite dish's texture is not requested until about the 47th. So the user is staring at an incorrect image for an incredibly long time while other objects that aren't necessary are being loaded behind them. So our general approach for solving these two causes, and by extension the problem, is to divide up the binary and to begin prioritizing the objects and their associated textures by whether or not they are in view. So to go into more detail, the way that your typical WebGL and WebXR scene is loaded is you have you first request the GLTF file, and then the GLTF begins requesting the binary, and the image is in arbitrary order. So for example, we have a scene here where we have the satellite object that is in view and the ground object, which is the rocks and grass around the user that they can't actually see because it's behind them. So both of these objects have their geometry data stored in one binary file, so at time equals 1, that gets requested first. It's a very large file, it takes a long time to download. Then, because the texture fetching is arbitrary in order, the rock texture for the ground object gets downloaded, and then the moss texture for the ground object. And now we have all of the dependencies for the ground object downloaded, we can begin rendering it, but the issue is the user isn't looking at them. So this doesn't help us make a correct image any faster than downloading things arbitrarily. The satellite object then is fetched, but much later, so the initial view that you look at is completely incorrect. Our approach starts with splitting up this gigantic binary file into much smaller ones, one for each object. The satellite object is in view and is prioritized, so the binary for the geometry of the satellite object is downloaded first at time equals 1, and then the texture for that satellite object is fetched without downloading any further geometry data for other objects. At this point, we can begin rendering the satellite object, which is in view, giving the viewer a much faster, correct view. We can then go about downloading the binary and the images for all the other objects that are not yet in view, in case we need them later. So the splitting of the binary is relatively self-explanatory. You figure out what byte ranges correspond to what objects, partition that into many binaries, maybe do a little bit extra to make sure that the byte alignment is maintained, but otherwise is relatively straightforward. The more complicated part is prioritizing these objects based on the initial view, and we had to come up with several heuristics in order to make sure that the prioritization of these, the download order of the objects was correct. So the first heuristic we could come up with was a simple view frustum culling. We parse through all of the objects, come up with axis-aligned bounding boxes that cover those objects, and quickly get rid of all the objects that do not intersect with the view frustum. That way we make sure that we never prioritize downloading an object that can't be in view. The second heuristic that we came up with was when we had the idea of, well, if we download all the objects that are in view first, that's great, but what about all the objects that aren't in view yet? Which one should we prioritize over others? And the general idea behind the second heuristic was objects that are closer to the center of the field of view are more likely to become visible than the ones that are further away. So we assign a simple look at rotation penalty. How far would a user wearing a headset need to move their head in order to see the object that's out of view, and penalize it based on how large that rotation is. We then combine these two heuristics into a final score and use that to sort the object requests. So the general overview of VIA can be broken up into two main components, an object scoring component and a partitioning component. The object scoring component will take as input the scene metadata file, or the .gltf file, and the user's initial positions and orientation for their first view. We will take the metadata file and come up with the axis-aligned bounding boxes by parsing that. We will then perform the rotation and view frustum culling scoring algorithms using the initial position and orientation of the user, combine those two to get our final heuristic. The second component of VIA is the data buffer grouping, or binary partitioning, where we take in the same metadata file, but also the binary file containing all the data buffers, and begin grouping them based on what meshes correspond to what parts of the binary, and then split them and come up with new metadata files and new binary files. All these are output in order of the object scoring. So the typical output looks like a large amount of GLTF and binary files that are sorted in order that they would be downloaded off the server when the client connects. We're going to now go forward for a quick demo. Okay, so for this demo we have WebXR running in Google Chrome. I am on a wired connection, but I am throttling the network to about 50 megabits per second, which is way faster than most mobile networks, but for the sake of time we do need these things to load in a reasonable time for the presentation. Alright, so we're going to quickly load a control scene just to show how this typically works. I do have the network log on the right side. So this is an indoor house scene. The skybox and the JavaScript and the GLTF load first. We are now loading all the geometry data, and as soon as it's done, it all appears at once. It takes many seconds for this geometry data to be downloaded, and by the time it has been downloaded, all the images have been downloaded and everything can just immediately render. But it does take many seconds for all of this downloading to occur. Now if we run the VIA adjusted version of this same scene, we see that the floor and the bed and the sink immediately appear. The walls load in a little bit later, and now we're continuing to load in all the other scenes that are all the other rooms that are not currently visible, but this room and all the objects visible were loaded far faster than the control. So now we're going to move on to the experiments that we designed in order to evaluate VIA and the results of those experiments. So we had 5 different test scenes that we selected for varying sizes, and not just varying sizes, but ratios of what types of data within that size. So some scenes where the geometry data was incredibly large and the images were small, and some where that was flipped. and some they were about the same size. We also chose scenes that had similar spatial arrangements and not similar spatial arrangements. So some that were completely enclosed, some that were open, some that were urban areas, some much more chaotic, and some without floors like a solar system. All 5 of these test cases we ran through all 3 of the systems. So we have the control where there are no changes to the binary, no change to the GLTF, no change to the images. The order is whatever the arbitrary order we got it from. Then we have VIA, where we split up the binary and we prioritize the images in the object ordering in order to see if it will go faster. And then we have VIA image, which, if you recall, VIA has 2 components. VIA image is simply VIA, but without the binary splitting component. So we just reorder the images based on visibility, and we leave the binary as its original monolith. We take all of these test cases and we run them on 3 different network bandwidths and round trip times that are covering typical mobile network conditions. Our main finding was that VIA strictly has lower latency, that is the time from the point at which the page loads to the first frame that is correctly rendered. VIA always has strictly lower time than the control. This time is even further better on slower networks. Very occasionally, VIA image will have about the same benefits as VIA, but most of the time it performs about the same as the control because both VIA image and the control require the entire monolithic binary to be downloaded before anything can be rendered. So when we looked at the different network conditions, we discovered that VIA's performance over the control does depend slightly on network conditions. Typically, the slower and worse your connection, the better VIA will perform when compared to the control. The only trade-off really for VIA is that VIA introduces extra round-trip times for resource requests. If you have one gigantic binary file in order to download all of the geometry, you only have to send 1 round-trip time request in order to get that file to start downloading. But if you split it up into like 400 files, you now have 400 round-trip times that you need to account for. Typically, this is an incredibly short amount of time, measured in milliseconds, so on slow connections, it's almost always worth it to split up the binary. The main variable that will change how well VIA performs over the control is what initial view you choose within the scene. We ran an experiment on one of the test scenes on one of the network conditions to see how a different view would affect the latency, and found that it's incredibly important. We ran an initial view where only a tree, its leaves, and the ground immediately surrounding the tree was visible within the initial view. So we had to download 3 objects out of 423 and had incredibly faster results than the control. We also ran an experiment where every single object was visible and saw that the latency was about the same, which is what we expected. Somewhere in the middle, you get middling results, of course. One of the main things that occurs when you're wearing a headset and you're loading into these images is that you have a camera that's attached to your head, and it takes some time for the scene to download. So by the time that the scene is done downloading, your head may have shifted, you've shifted your weight, tilted your head to the side, and the initial view estimate that the download started with may be different from the initial view after it's done downloading. So we ran an experiment to see how well VIA performs if the initial view is slightly off from where we expected it to be. Just simply rotating the user's head in 15-degree increments and measuring the change in latency, we discovered that VIA continues to outperform the control until you look more than 90 degrees away from the initial orientation, at which point VIA begins penalizing objects more than the control would. So as long as the user is looking generally in the direction they were originally, VIA continues to outperform. So I'd like to thank you for attending this talk once again and ask for any questions.
Thank you, Carter. Again, I remind people they can answer or ask questions in the chats available in Whova or Ace. Carter, I don't, let's see. I will start with a question. And you mentioned forming in your analysis the view aligned limiting box or bounding box, perhaps.
Is my mic working? It's just an axis aligned bounding box. It's
okay.
The,
and I may have missed it, but does that require? Is that in the metadata already, or does that require analysis of the points of the bin file?
yeah, I was surprised that it's in the metadata file. It's
okay.
The extremes for all the vertices are contained
okay.
within the metadata file.
Okay, so then that leads to my follow-up, and it's kind of speculative, and maybe you thought of it, maybe not. If you had your if you could adjust GLTF or some other standards metadata, is there any other geometric information that would be compact, appropriate for metadata, but would be useful to have in the metadata so you can quickly use it in this type of optimization?
If I was going to change anything about the GLTF format, it would be some way to specify what order you would fetch these objects in. But having additional information, it's kind of difficult because the only thing that we had problems with was animations. Maybe you have an object that starts on one part of the scene, but it comes into view, and we can't figure that out just from metadata information. But that's sort of a niche case.
Well, I guess I'm thinking about, because you did the other analysis where you analyze how far you would have to or what things are just sort of maybe just out of view that someone would only turn a little bit to see. Is you know, I'm trying to think if there's some other quick, you know, anything else that the content author could put in metadata that would help that kind of analysis.
Maybe some sort of standard for initial viewpoint, because that's renderer dependent. WebGL defaults to 000 and looking down the z-axis.
Okay.
And then you can specify an object, but you can call it camera, you can call it initial camera, you can call it initial view. So it's difficult to parse in. So we just have it as a command line argument.
Right. Okay, I note that there's been another question submitted to chat, and it's similar to one I was about to ask. So this is from the Visual Computing Lab, and can the person authoring the scene add an additional level of weighting for the importance of the geometry?
Not in any 3D modeling software, and not in any GLTF generator that I'm aware of. That would be nice. What you can do is go in after you've generated all of these, you split up the binary files and the GLTFs and the images. You can go in and just change their names, because the way the renderer works right now is it just says, so for example, you take the Sponza scene and you have 300 objects. They're just labeled Sponza 0 to 300, and you just swap out the order manually. You could do that. But if you wanted to, add a plugin to say Blender that allows you to like check mark something, say always down this first, that would be useful.
Well, the variation that I was thinking of, and this is important in computer-aided design models, is sometimes you have a model where there'll be a large assembly and they have a separate mesh for every bolt, nut, and bolt. But very often the person looking at it doesn't really care about the nuts and bolts. Do you think in your work, you have those bounding boxes, have you ever thought of just omitting things which are small?
Fully contained within another bounding box?
Inside, or just geometrically? I mean, you
made too small to be significant.
To be seen.
Okay.
And you mentioned the satellite dish. I don't know to what level those are rendered in the VR scene, but if they've rendered in their GLTF all the little cables and things that go to a satellite dish, but if you're across the street, you know, you don't see it.
Right. I don't believe we had any objects that small in our test cases, except for there was a shack scene that had small, like half rendered soda cans just in the
Yeah.
background that weren't necessarily visible. So there could be some analysis on, okay, how expensive data wise is this object to render, and how much of a view frustum does it take up?
Right.
So there's room for extra heuristics and all these other things that you can extend the technique with.
Okay, let me again ask any, we do have perhaps a few minutes. If there's any other comments or additional discussion people would like to have, and let's see. Okay, thank you, Carol. Card, I don't know whether you can see the question from Carol McDonald. She's asking about, could you zoom into smaller objects, which is a little bit related to the discussion we just had about.
Mm-hmm. Well, if you could, I struggled to think of a practical, a real world case where you would have your initial view be completely zoomed in on one object. Although after everything's loaded, you could definitely, move your headset really, really close to some very small virtual object. This project only cares about the initial view, the initial load time. So you definitely wouldn't want to completely omit those smaller objects, but maybe you would penalize them till later because the initial view doesn't focus on them too much.
Okay. Carol says that works. Okay, well, thank you, Carter, for answering our question and for the interesting talk. I think that it's appropriate to wait until the scheduled time, and it's about 4 or 5 minutes away for the final talk, just so anyone who particularly wants to see that entire presentation. So I guess we'll call this a few minutes break to refill your coffee cups or whatever you're drinking, and Carter is available, and Dr. Paulus from the previous talk, and Rick. So we have a few minutes to catch up with questions, maybe perhaps on the previous presentations, and then in about 5 minutes we'll start with our final paper from the session. Hey, Nicholas, if you're still there, I know you're muted and not visible, but since we have a few minutes, I wanted to bring up a great question that Carol asked about. Well, she asked in the sense of putting one of your sensors on migrating sheep, I believe. That kind of brings the idea of bringing dynamism into your classroom. That kind of dynamic virtual reality. Is that something you've thought about, the possibilities? Maybe. Oh, okay.
Yeah, thanks, Vince. Yeah, we've, well, it's been kind of a mixed bag, in terms of the animations for the photospheres themselves. We've tried some time lapse approaches, right? Which is sort of like like you would imagine a time-lapse imagery. Some of the things that we have been animating are, for example, down on our stream lab, looking at the different rain gauges and flood gauges and stuff. So we are able to actually animate, for example, the water level of the river based on what it actually was on that date or for a certain flood event. But it's been pretty simplistic, I have to admit, to this point. So it's a good suggestion.
Right. And the other thing, this is kind of off topic from perhaps a little bit, but in the archaeology session we had yesterday, the topic came up was these VRs also give you the ability to go places where your presence would, if you actually bought a class to a natural site, they would damage it. Is that something which is a factor in your, in the kind of work you're doing?
That's a great point. We haven't really come across that in our experience so much yet. There are a few locations that we do have to sort of keep secret. For example, there are ginseng hunters, for example, that will go around and take plants from the national forest or whatever. So there are certain plots where we actually obfuscate the GIS data so that people can't find them. That's a good, interesting scenario.
Well, I think about there are places in our national park system which have a very strict, if you bought it in, you have to bring it out, and that includes everything. So yeah, that's kind of hard with a bunch of grad students.
Yeah.
Okay.
Funny. Yeah. There was we have done a deer hunting game on one of our properties, which was paper a few years ago. It was about level of detail for trees and how we can do picking through these different kinds of models. So not too far off about the bear hunting.
Yep. Okay, I think it's about time to move on to the fourth paper of our session. And this was also at least partially the topic of a tutorial, a very interesting tutorial earlier in the conference. So the title for this paper is X3D Audiograph for the Consistent Declarative Representation of the W3C Audio API. So if I can ask if we can start that recording. Thank you.
Hello everyone. This is a presentation about the short paper X3D Audiograph for the Consistent Declarative Representation of the W3C Audio API. First of all, let me introduce myself. My name is Eftichia Laka. My background is computer science and I am a PhD candidate in the University of South Wales in UK. In this presentation, first I'm going to provide the basic concept of spatial sound propagation for the design of a 3D virtual environment and highlight the motivation of this work. Then I will share with you the overview of the method and the idea behind. Analyzing a specific developed example, I will focus on the audiograph concept and why it is useful to be used, and some implementation expectation. I will end with a conclusion and with the strong points of this work. Let's start with a first glance, what is spatial sound? For several years, great effort has been devoted to achieve high quality visual rendering for the development of interactive virtual worlds. Considerable attention has been paid to engage multiple senses in 3D applications. So the researchers understood that a vital factor to improve the immersion and realism for the user experience in a 3D environment, both visual and auditory rendering is needed. So as a result, the attribute of spatial sound propagation for the design of a 3D virtual environment has needed to be undertaken. And beyond that, there are similar efforts in Web3D applications with contribution of the immersive audio. Therefore, if we need to give a definition of spatial sound, we can highlight this one. The listener can recognize meaningful spatial cues from a sound source, for example, the direction, the distance, the spaciousness. It recommends a procedure in order to define the audio flow from scene source, often an audio file, to its destination, often speakers, through sound effects, and generally mimics the sound in the real world and provides a more realistic and immersive auditory environment. Motivated by the above, this work aims to integrating acoustic properties associated with geometric shapes together with 3D spatial sound in version 4 of X3D, focus on representing the sound process and activation profile model, providing a rich audio graphic description in X3D. And to be more specific, this solution is designed in which the specification of X3D nodes are harmonized with the corresponding WebAudio API nodes, taking the advantage of the representation of audio nodes routing graph structure. Before continuing with the main idea of this paper, it's worthwhile mentioning that this proposed solution is the result that is coming from our systematic work and different publications until now. Namely, we introduced the first approach of spatial sound components in X3D framework based on the current X3D specification and WebAudio API in 2015. In 2018, we tried to have a systematic survey in order to understand and clarify the background and the most relevant algorithms for spatial sound in the literature. A year later, we tried to go deeper and research the acoustic properties of the sound. In 2020, we suggest a structure of a new nodes in order to extend the X3D specification, harmonizing with WebAudio API, both with spatial sound attributes and with physical effects which are involved in sound propagation. After that, this proposal was accepted for the extension of X3D 4, and now in this work, we aim to determine the best way to connect X3D nodes, making up an audio graph, at the same time creating a large set of example audio graphs that capture the full richness of a WebAudio API, revealing whether remaining design issues are resolved satisfactorily. In the next slides, I'll try to give an overview of the method. First of all, the audio graph model that we proposed. As I mentioned, the main purpose of this work is to harmonize X3D language that is used to represent 3D content in existing adaptive high-level API for processing and synthesizing audio in web applications, of course. WebAudio API is essentially a graph of nodes that process the signal. Thus, if we could turn this graph into a visual XML-like tree, it will be easier to understand, manipulate, and reuse it through an X3D scene. How this has been achieved? By the introduction of native X3D components with a few lines of code that are explored. Next slide. X3D uses a scene graph to assemble all the nodes that make up the virtual environment being modeled. The scene graph is a tree structure that collects all aspects of a 3D scene in a hierarchical fashion, properly organizing geometry, appearance, animation, and event routing. In the same way, the proposed X3D audio graph consists of the corresponding syntax that offers features for configuring a hierarchical structure audio graph with any number of connected audio nodes. All the above will be more clear with the next X3D example and its explanation. Let's go to the next slide. Explain a little bit more. In order to verify the validity of our design and proposal, the new register node in X3D and the proposed structure were applied to several examples that were already implemented. One of them is depicted in this slide. We use X3DOM to create 3D scenes and animations through HTML. So in the following example, there are two sound sources in different positions. Through the immersion in the X3D scene, the user could attend a rational navigation. Whenever the camera moves in the direction of an existing sound source, the strength of this source increases, while the sound strength of the other decreases, and vice versa. So this is the example, the idea of the first example. Can be represented in WEB3D code that you can see in the left side of this slide. And in the right, you can see the corresponding hierarchical connectivity of nodes and the resulting audio graph, let's say. This means the audio nodes in an WEB3D model can be declared using XML nested elements, where the parent-child relationships represent the connection between nodes in the audio graph. The structure starts with a topmost audio element for its independent audio graph. The inputs to each node are provided by its children, and similarly, the outputs of each node are provided to its parent. Let's continue. So we have the audio destination node, first of all, as the parent element of any other audio node. It represents the final destination of an audio signal and is what the user can ultimately hear. And in the graph is this last node. Accordingly, there are two sources that are passed through separate spatial sound nodes, one of the most important nodes in WEB3D, for the specialization of the input audio. For each source, a gain node is used to amplify or de-amplify the input signal, and an audio clip for emitting audio data. So this technique is structurally consistent with a corresponding, here it is, corresponding web audio API source code, as you can see in the bottom right graph, which is represent the nodes and the connection in web audio API that are needed to implement the previous example that I have already described. So, which is the result, the advantage of this procedure? Understanding the tree form of WEB3D models is sufficient to utilize the translated audio components, and no further knowledge is needed regarding JavaScript programming of Web Audio API framework. Consequently, users with WEB3D modeling background can use the proposed audio framework to develop and integrate interactive Web3D scenes, including immersive spatial sound. I will continue with some implementation expectations. The first one, for acoustic properties, besides the previous proposed solution that I have already described, the registration of new nodes, which include physical effects, has been already proposed. Particularly, acoustic properties have been introduced that are involved in sound propagation, such as surface reflection, specular diffusion, and wave phenomena like refraction and diffraction. By taking into account the geometry of the scene, increasing the perceived audio fidelity of virtual scenes acoustics. In this figure, you can see and the explanation of this definition: specular diffusion, refraction, and diffraction phenomena. Our initial implementation focused on the prediction of reverberation time in enclosed spaces using simple numerical solution, which provide a simple acoustic model but retains the essential acoustical properties of the room as accurately as possible. Such geometrical simplifications can often reduce computational costs significantly without a reduction in perceived audio fidelity of 3D scene acoustics. Specifically, the idea is to simulate a real-time ray tracing model that takes into account the interaction of sources, listener, and the virtual environment in a 3D scene. Some of these interactions include absorption by air molecules, air attenuation, and by the surface in the virtual environment, like material absorption, specular or diffuse reflections, diffraction and transmission through surface, etc. Our next implementation will emphasize materials of surfaces for the sound propagation, which are described by absorption and scattering coefficients in different frequency bands in this time. The evaluation of the algorithm will be by experiments using real rooms with the same sound, let's say, characteristics and geometry, in order to investigate and compare the results of the algorithm with real audio measurements. A further interesting approach is to create an application that has the potential of becoming an authoring tool for theater directors, actually giving them the ability to produce theatrical performance while offering real-time control over the sound and visuals of each scene. Namely, the application, the idea is primarily concerned with sound specialization and multi-user connections combining Web Audio API again and X3D4. The WebRTC technology is used to create peer connections and exchange audio, video, and binary data. The selective forward unit of WebRTC architecture allows multiple people to connect together, either as performers or spectators. Current work demonstrates that streaming mechanisms can work through all declarative and imperative forms. Both acoustic properties and media stream techniques, which are proposed and analyzed, prove that we provide a complete set of capabilities for Web Audio app processing, matching with the Web Audio app. The conclusion, as a final point, X3D4 graphics offers new exceptions, providing advanced 3D spatial sound propagation. The purpose of this work is to analyze and present the concept of the audiograph of oralization in a 3D scene, which is central to the composition of X3D and W3C Web Audio API recommendation. The evaluation of specific examples proves that the interactive virtual scene can be composed with the use of X3D register audio nodes, and the results confirm our methodology. Also, the implementation expectations are presented for more complicated 3D scenes in order to achieve the expansion of the field of immersive sound beyond the limits of the no-interactive approaches. So please, you can visit the below link to have a look in our examples, and of course, more details are presented in our tutorial of the conference with the title Modeling Examples Extending X3D Realism with Audiographs and 3D Spatial Sound. So this is the end of my presentation. Again, I am Eftichia Laka, and my email is available. Thank you very much for your attention. Thank you.
Hey, thank you, Eftichia. Thank you, and for setting up your visualization. And I will ask, perhaps, if there's someone who has access to that PowerPoint, perhaps they could put that link in the chat, since it's, thank you. Are there any questions? I have one which is very strictly a non-expert question, so I'll give. Oh, thank you. It's in there. Okay, I will start things off. If you can quickly say yes or no. I'm at the level where sound, my knowledge starts at the difference between stereo and mono playback. Is the work you're doing, does it include stereo? That is, if you have a headset seeing two different sound sources in the two different ears?
Yep.
It does, okay.
Actually, if you see the first examples that we developed, that's the first step for us, to specialize the right and left.
Okay.
So we have an audio source moving left and right, and the user can hear it from the corresponding speaker. So the other, let's say, interactive example that we developed is to have a 3D scene, two sound sources in this example, and the user, let's say, flying in the scene, and for us, the camera is in the ears of the user.
Yes.
And when we go close to one sound, we can hear it. And the opposite when you go away. This is the idea. Of course, as you mentioned, we have a detailed tutorial about this. We explain which is the nodes of Web Audio API, and give a high level of the definitions, which the new nodes, audio and X3D, and why would we choose to harmonize with them. The idea, but focus this paper is to explain the how can we describe in X3D this graph, this audio graph, how connect, because one of the advantages in Web Audio API is this, to create your code, but if you see all the nodes, you can be like a graph, a tree, and started with from the audio buffer and finalized to the destination. This advantage try to have it in X3D, and of course any suggestion it's welcome, of course.
Okay. Carter asked, and obviously he's thinking of his work about optimizing loading, and this may be perhaps an implementation question, but I'll ask you, he brings up the idea of asking whether these audio sources have to be loaded all beforehand in a similar way that his work discussed geometric resources.
For these specific examples, what we do, we use the X3D. We use X3D for us because, as we see in the presentation, it's systematic work for us. So we started the first demos, let's say, with X3D. So this is, but it is not. Let's say we can use everything language that you want. For us, X3D is standard. WebAudio app is in a JavaScript, but we can manipulate it in any language that you want. From us, it's X3D at the moment. Does the mess with the sound propagation? And yes, until the object have loaded. Yes, this is the answer. But try to be more, let's say, more interactive on this. Yeah, this is the idea. To clarify that the examples, maybe it's not so 3D, wow, etc., but we try to use all the proposed nodes in order to identify that it's working. It's not only theoretical, but we can use it in practice. And if you have the opportunity to see the tutorial, we have another example from our colleague Maria that tried to have a platform using WebRTC, because WebAudio API has different nodes from WebRTC to input and for output. We introduced this in X3D, so we'll try to have a platform specifically for the guys that try to create a theatrical area, and any performers, any singers can be linking from his home like this, and we have the final scene, not virtually. This is the idea, and like Zoom to change data from the audio, etc. I mentioned that we have proposed another node with acoustic properties. This is the area that I try to focus on right now, to have some reflections of the objects. So after that, maybe from material, from walls. The first initial development tried to have the light algorithm on this, but have a better result in a closed room, let's say, in 3D. This is the idea.
Yeah.
And from my side, I believe that we'll try to have a solution not so difficult for people that is not programmer. For that reason, we'll say that okay, let's have the XML tree, and don't use anything from JavaScript to create all this special sound. I don't know if somebody from the co-authors would like to add something. Don Bratzman and Richard is here, of course. They are helping me very much to integrate and to implement it and finalize the X3D audio nodes.
Well, I'm looking at some of the questions, and okay, William has brought up the issue of temporal things, and it makes me realize in our current X3D standard scene, we really don't have the concept of velocity of an object in our scene graph. And in the oralization, because the speed of sound is much smaller than the speed of light, the velocity of a source can actually, affect the way it sounds to a stationary viewer. Is this something which is already included, or is this to be a future enhancement to account for the Doppler shift?
At the moment, we borrow the specialization algorithms from WEB3D API and the functionality. So in this, the most important things that we have, we have the listener and the source,
Right.
and a specific node based on HRTF or another additional algorithms can calculate which is the sound and how can we rendering this. This is the for us at the moment. Yeah.
Okay.
Of course, in literature, we saw that a lot of things from lighting can be in sound, but in more easy way than light, let's say.
Right.
For that reason, try to have the next development, and maybe we can have I don't know some algorithms from a light to be adapted for the sound.
This is Dick. I thank you, Effie, for an excellent presentation. There are many opportunities for future work, including how do you adapt to different transmission mediums. For instance, sound underwater is a lot different than sound through air. And I think this is all things that we can be working on in the future.
Yeah. Yeah, it's a good, and we try to discuss about it and find the first step.
Are there any further? I'm looking at the different chats. I do not see hands up or further questions. I see that I believe from the visual computing lab, I'm asking about collisions and scattering. That is a very complicated problem, I think.
Yeah,
perhaps you can answer that in 2 minutes.
Yeah, it is. The first very simple algorithm to try to do right here is to have the reverberation, let's say. But okay, for us, it's step by step to understand the physics, to understand the X3D, and after that, include all of this.
No, sorry, it was it came out to convolute the question. I was just saying that now when you create interactive 3D app, a lot of time you have the geometry that you render visually, and then you have to create also a very simple geometry that is used for navigation and collision with the wall or teleportation. And probably if we want to go with spatial sound, you will have to give yet another geometry as simple as this one that is used to compute this echo and scattering and occlusion also for sound. So even more work for altering a 3D scene for interactive use. It was just a comment, not something that you needed to add to your work.
So that's try to do. It's very simple, of course. Try to have some object in a 3D scene, have some material, and when we have the sound here, we can use which reflected, which absorbed, etc. But okay, step by step this one. Because I should notice that all these new nodes in X3D, it's after a lot of discussion, because okay, we have it like a pattern in the WEB3D app, but after discussion, we find a lot of things that we should add or change, etc.
Okay. Well, thank you to obviously all of our presenters, Effie, for the very interesting presentation and for the tutorial earlier this week. And all our presenters today and our other co-authors and colleagues who sat in and helped out with some of the questions. I know that we've already have some people arriving for the next Geospatial Summit. So I invite everyone to stay for that. But as presenter, it's been a pleasure, or as chair, it's been a pleasure chairing this session for you all. And again, thank you for you and for the audience. So have a great day.
Thank Vincent. It was a lovely session. Thank to all the presenters and thank to everyone that attended the session. So we can have a few minutes break while we move people from one side of the presenting line to the other, and let's get back to 5-10 minutes. Thank you all.
Thank you.
Thank you.
Good afternoon, everyone. I'm trying to get Peter at Cesium and Tamara at Esri set up as panelists and to get their presentations loaded. Marco, if you can assist us.
I think Peter Sforza is already a panelist and should be able to turn his camera and microphone on.
Right.
Tamarat, I believe it's signed up as TAM-B, so I believe,
yes,
perfect.
I am. Yeah, I will change
and
my.
It's no, but we found you.
That's
You're already you're a panelist, and
all right. And
Another Peter.
I need Peter Gagliardi, please, also.
oh yeah, sure. Should join in.
And hopefully Peter is on right now.
Yeah, he was among the spectator, and he asked before if the session was the correct one. So,
okay.
Yeah. It should be coming now.
Okay, great. Thank you.
And John, as far as the presentation, I think share screen is enabled for me at least, so I can directly share from my computer.
That's fine. Yeah, if you and Peter just want to share your screens, that's fine.
If anyone want to try sharing a screen and starting whatever they need, please feel free to do so.
Okay.
And we tell you if we see things happening.
Well, let me try then in that case.
Thank you, Tamara.
You see my slides?
Yep, they look
Yes.
great.
Right.
Perfect.
Very good.
Okay, Peter, do you want to try yours? If he's on.
Peter Gagliardi.
He just loaded up another comment in the chat.
Yes, I'm trying to move him to the member. He disappeared from the spectator, but then it does not appear as a member. No, again.
There he is. And then he disappeared.
Okay.
Hi there. Can you hear me okay?
Hey, Peter, do you want to try to share your screen real quick?
Yeah,
The
sure.
presentation, let's make sure it's working.
Can you see my screen and presentation?
Perfect. Awesome. Thanks, Peter. I appreciate it.
Yeah. Yeah, I guess, what do you want me to do with my slides? Do you want me to like upload it, and if so, what format?
Well,
Yeah, why don't we just have you share your screen? We'll have you upload later for the record.
I think you have a good connection, so I can see the slides perfectly. So it's fine if you want to present live. Yep.
Okay, cool. Yeah. Yeah, sorry, like it seems like every time you hit settings, like it kicks me out of the call. So you know, it's I'm on a Linux laptop, so that might be it.
No, the fact is when you get promoted from it just go out of the session and then just enter back.
Yeah, yeah. Cool.
All right, Nicholas, I got you. Okay. Well, whenever we want to start, Nicholas, if you'll kick things off, I'll kind of be ready to jump in. Okay.
Sure. And Marco, are we recording? So,
which one should it be? Because you sent the SIGGRAPH one this morning, and
no, I'm sorry. No slides. I just want to make sure we're recording the session now.
Yeah, the session is being recorded and it's being streamed on YouTube.
Okay, great. Well, I'm sorry I didn't get the memo right away there. A little bit tired today, but I'm really excited to be here in this session with you all. My name is Nicholas Paulus. I'm the president elected of the Web3D Consortium. And, we missed you guys so much from our last SIGGRAPH BOFs that we had to do it again. And, we have really constructive, I think, dialogues when we do get together. And so I wanted to thank you for attending and thank John Ouellette from Versar for organizing this. And I won't get in your way. I know we have lots of fun stuff to talk about. So thanks, everyone, and welcome.
Thank you.
All right. So based on our agenda, Tamara, you want to go first?
Oh, sorry. What are you talking about me? So,
Yeah.
Sure.
I think we agreed Peter was going first. Peter,
yes, that's what I thought.
Yeah. Okay.
Yeah. Sorry about that.
All right. Let me share my screen again. Everyone can see that. Okay.
Yeah, Peter, looks great. Thank you.
Cool. All right. Well, hello there. I'm Peter Gagliardi. I'm a software developer at Cesium. I'm on the 3D Tiles team where we're building the next generation of 3D Tiles. And today I'm happy to be here at Web3D to talk about 3D Tiles Next, our new draft extensions for 3D Tiles, which are now open for community feedback in GitHub. So 3D Tiles and Web3D actually have quite a bit of a history. So our CEO, Patrick Cozy, he's presented at Web3D a few times in the past. So like once in 2014, just a little bit before 3D Tiles was created in 2015, and then soon afterwards in 2016. 3D Tiles has since, in recent years, become, an OGC community standard. Like it's always been an open specification, and it's become a lot more prevalent over the years. It's a big part of everything we do here at Cesium. And now, as of like this week, like literally yesterday, we are announcing 3D Tiles Next. We're making extensions for 3D Tiles. They're all open specifications. They're all available for community feedback. And at the end of the presentation, I'll give some information about how you can get involved with that. So I guess is there a good way to give like a show of hands of like how who's familiar with 3D tiles already? I guess I'm not familiar with the Zoom controls for that, but I don't know if there's any way to do a show of hands. In any case, anyway. Well, in any case, I'll give a quick overview of 3D tiles for whether you've seen it before or just and need a refresher, or if it's completely new to you. So 3D tiles, it's an open standard for streaming large, massive geospatial data sets. Everything from everything from terrain, photogrammetry, point clouds, 3D models of buildings, etc. And even though that this data comes in many different formats, we make one big format optimized for runtime streaming. Great for visualization and analysis. And some of the cool things that make it work, is it's very flexible. You can represent a lot of different spatial data structures, everything from quad trees, oct trees, KD trees, however you want to define a bounding volume hierarchy. All our tiles, the tile formats are all designed to be runtime ready, and like being able to just upload it to the GPU and display it. And GLTF is a big part of that. That's an that open standard from Kronos, and that that provides us like a 3D mesh format that that's optimized for streaming. And one of the cool parts of that is and then on top of that, we want to like have metadata to be able to label, say like, hey, this group of vertices, we can identify this as a building. And what's more, you can add metadata properties to be able to say like, hey, here's the height of the building, here's the occupancy, and so forth. So that's 3D tiles as it, very quick overview of 3D tiles as it is today. But what does the future look like? And we're building it so that we can make support like increasingly massive data structures, data sets. And we want to have like these metadata properties. We want to just make it a much richer environment, make use of like AI classification and be able to store that efficiently in 3D tiles. So that brings us to 3D tiles next, are these new draft extensions for 3D tiles. And we have a few big goals for that. So one of them is just to make the integration with GLTF cleaner. Again, GLTF has always been a big part of 3D tiles, but we just want to just streamline that a little bit more. We want, again, be able to include meaningful information. So we want to have metadata and just make that more robust, more efficient. And then implicit tiling, we want to optimize, cases for massive simulations and analytics. Quad trees and oct trees are pretty common, so we want to, we found some ways to optimize that a bit. So to the first point, integration with GLTF. So we have a format, extension called 3D tiles content GLTF, and the extension, works pretty simply. It just allows you to say like, hey, the content of a single tile in a tile set. You can basically just say point to a GLTF file now, and it'll just directly work. And the point of this is just kind of simplify things. Like we had formats like batch 3D model, i3DM, instance 3D model points, and whatnot. And a lot of them, they're essentially wrappers around GLTF. It's like, for example, B3DM, it's a GLTF with a small binary header and a batch table, which gives you some like metadata properties, at the vertex level. And now we're trying to like re-express that in a simpler way. So it's just going to be a GLTF with, now it has an extension. This new ext mesh features extension is our metadata extension for GLTF. And, so that just kind of keeps it a lot simpler. So now you can make use of other, existing GLTF tools. And the cool thing, and like all the other formats are pretty similar, and even point clouds can now be represented in GLTF, since GLTF does support point primitives, and then with ext mesh features you can store all the other properties. And the cool thing with using GLTF in everything we do is is like there's a lot of cool tooling and extensions out nowadays. For example, some of the recent extensions are like compression. There's KTX2 for texture compression, meshup for mesh compression, GPU instancing, which is a detail of how instance 3D model format, how that can be converted to GLTF. And then, Khronos has PBR Next, so there's lots of new PBR materials for, better looking models, specular, clear code, sheen, and so forth. Certainly those can be leveraged by 3D tiles now. So the second big point is metadata. So if you want to make a virtual representation of the real world, so I mean, of course, one big part of it is getting good quality data, getting nice photogrammetry, and so forth. But it's even more valuable if you can actually imbue that with information like meaningful information about what is this data. So be able to say that, hey, this scene of a building, like here's a window and here's a door, and even further properties about them. So be able to say that, like, hey, this wall is made of concrete, this window is made of glass, so it's like a transparent material. And some of those this classification is can be come from, say, like AI and machine learning to be able to divide up a model into different classifications. So, how do we make this into, a format? So, one of the things is we want to just, again, with the batch table, we had some amount of metadata capabilities, but we just want to like make this more robust. So one of the things is we want to like expand it to more levels of detail. So the levels of granularity, excuse me. So we want to go both finer grain. So in the GLTF extension, not only do we have vertex metadata that, which is essentially what we had before with batch tables, but now we even want to have like texture metadata as well and instance metadata. And then on the flip side, we also want coarser metadata to, just to make it more flexible. So like, for example, if you might want to just have some information about the tile set itself, as far as like, who's the what's the attribution for it, and so forth. Tile metadata might be used for like, we find it useful for like, storing performance information, so that can kind of optimize things at runtime. And, plenty of other things you can do with that. And the design is designed to be decoupled a bit, so you have like the type system, which is kind of describing what is the metadata, like what metadata properties exist, what types are they? Are they, is it a vector? Is it a string? Is it an integer property? And you can define whole schemas like that. There's the encodings, which is how do you store things? How do you actually store this metadata? Do you store it in binary, which is great for like, inside of a GLTF, you want like, very high frequency, there's a lot of data, so you want to store it efficiently in binary. Similarly with textures, we want to store that in some sort of image file. And then for coarse metadata like tile set, you only have one tile set, so JSON is fine. And then semantics is another layer on top of that. So for example, like, a single domain, so like, something like AEC or something that, you can, an industry can come up with a set of semantics, set like a common schema, that everyone can share, that, so, hey, we're all going to support these properties that are meaningful to our industry. So now if I make a data set here, I can, pass it to your application and it'll work. And, so it's designed in a way that can be used interoperably. Another thing I just wanted to highlight is the texture metadata, which is a new feature that's pretty neat. Because it allows you to do much higher frequency metadata. So, and there's kind of two different flavors of it. There's property textures, which lets you, for data that varies from point to point, like, for example, think of like a heat map on a surface where every texel is going to be a different value. You can store properties like that. And then, but then for, say, like a photogrammetry use case where you're, you want to classify things, feature ID textures are great for that, where instead of storing the value, you're just storing which feature is this texel belong to. So for example, is this, maybe a 0 represents a wall and a 1 represents the roof. And then from there you can look that up in the table of like, okay, the wall has these properties, the roof has these properties. And just to show this, I have a live demo for you of, example of feature ID textures. So this data set provided by Airmetrics, it's a street level photogrammetry data set at sub-centimeter accuracy of the ferry building, or well, part of it, from in San Francisco. Now, I haven't personally been to San Francisco, but I've heard this is a very well-known building. So, and to show like the classification, like I showed you before. So now I can go in and like I can hover over, say, like the windows, and like, you know, I can see like, okay, this is ID0, walls ID2, and so forth. And like the clock is something else. And one of the key benefits of that is it lets you do a lot of custom style, like much more sophisticated styling and whatnot. So for example, I wrote a shader here that you can basically say like, hey, the windows, I want to make them transparent while keeping everything else the same. And you can go further, like, since this is in our open source Cesium.js experimental implementation of this. And since we use GLTF, we use PBR materials, so I'm able to like kind of play around with it to be able to say like, hey, for each classification, use a different material. I can, for example, make the clock extra shiny in metal. I can make, even while making the windows transparent and so forth. And you can do like interactivity as well. So I can basically say like, I'm going to click a feature and highlight everything in the feature. And, I was kind of going for like the Midas golden touch, to make it all shiny, whatever you select. So there's plenty of cool use cases that come out of this. And then another big point is implicit tiling, for making big scalable simulations and whatnot. So it comes from the observation that like, quad trees and oct trees are, pretty common spatial data structures, and they have a nice regular structure. So you don't have to store every little bounding volume. It's kind of redundant. All you need to know is, okay, here's the main bounding volume, and that it divides nice and evenly, in 4, or for an octree 8 smaller parts. And then all you need to do is being able to like label each tile. So we use a like level of detail, and then X, Y, and for octree Z coordinates. And then all you need to do is for each tile, you just need a single bit that just says, hey, if there's data here, store 1. If there's no data here, store 0. So that makes it more compact, but the real benefit is it provides random access, because now every tile is labeled, by these coordinates. And this can accelerate certain types of queries. So for example, if you're trying to do a simulation and you do need to do a lot of nearest neighbor queries, now instead of having to traverse the whole tree, you can basically say like, hey, I know I'm in like the coordinates I'm concerned about are here, so I can just like select out a region around that and then like look at just those tiles. So, and there's plenty of other algorithms and stuff that this can help with. And so then another extension that pairs very well with this is S2 bounding volumes. S2 is a different tiling scheme for, that's great for worldwide tile sets, data sets, with the goal of, reducing distortion, especially at the poles. Because one thing with a lot of, cylindrical projections, say, of the Earth is like, anytime you try to make the Earth flat, you're going to introduce distortion. And usually that shows up at the poles. But sometimes you do want to map the poles, so this kind of evens it out. And to show you that, I have another demo here. This whole base globe. So this data set is provided by Maxar, and again, the big deal is trying to make the poles actually look decent. So if I turn on the bounding volumes, you can kind of see what's going on here. So S2, the way it kind of works is instead of using like a cylinder or cone for projection, it's basically using a cube, and and then projecting that onto the sphere, projecting that onto the shape of the Earth to make like a nice evenly divided projection. And that provides like equal area tiles, but the key thing is it's kind of, instead of having all the distortion in one place, it's kind of spreading it out over the entire globe, so no place is super distorted. So that makes it great for the poles, and and just each tile is pretty uniform in area. And the other thing is, even though that like the tiles might look a little bit weird, they do divide nice and evenly. So this is why it pairs very well with implicit tiling, which is all quad tree, not tree based. And you can see like as I divide, as I zoom in, like each one subdivides into 4. And just a couple other things about this particular data set. I do have a feature ID. This does come with feature ID. This one does come with feature ID textures, so you can label like this is like land cover classification. So you can say like, hey, here's water, here's vegetation and grassland and so forth. And of course, you can style with that. I can like just style the water, for example. And then just another thing about implicit tiling, just to kind of compare it with regular 3D tiles, which we sometimes call explicit tiling, and because they both have their place. Explicit tiling again is very flexible, and that and that's still can be very useful. And where and you do that by listing each bounding volume and divide space how you want to, or how it's useful to your application. Meanwhile, implicit tiling, again, it's quadrinoctree and it's a lot more compact of a format, which is, so you just declare one region and then one bounding volume, and then you just have template URI patterns for like all the contents and everything. Remember, you use level X, Y, and sometimes Z coordinates to select things. And then remember I said like there was you just need like a bunch of bits to kind of say which tiles exist or not, and those are stored in what we call subtree files, and those can also be found by similar manners. So it's nice and compact. So what's the future look like for 3D tiles next? So again, we're opening things up for feedback in GitHub, and as we get that feedback, we're going to revise our specifications. We have an experimental cesium JS implementation, which is how I made those demos. So gonna just keep continuing the open source development there. We want to bring it to other engines, such as Unreal and O3D. We have some sample data, but we want to keep providing more. Create some more tooling so it's just easier to get up and running with 3D tiles next. And we want to talk with the Open Geospatial Consortium and Kronos Group to like start talking about the standardization process of these extensions. So if you want to get involved, the 3D tiles next, the link there brings us to the 3D tiles repo, and that there's more information there. And there's also yesterday, Patrick, our CEO, had a blog post that kind of gives like the whole vision and goes into a little bit more detail. You can read that there. And cesium JS, the implementation, the changelog lists like all the new features there. So yeah, thanks for letting me present here at Web3D, and excited to answer some questions in the panel.
Well, thanks, Pierre. I really do appreciate it. Rather, because of time, let's just go ahead and go into Tamrat's next, his presentation, and then we'll save the questions for both you and him at the back end here. So Tamrat, do you want to go ahead and load yours up, please?
Sure. Thank you, John. Let me go ahead and share my screen. And do you see my screen? Okay.
Yes, everything looks good.
All right. Thank you. So this morning I'll talk a little bit about I3S, Index 3D, Index 3D Scene Layer standard, and how it is enabling 3D GIS to be pervasive everywhere in different platforms, from desktop, web, mobile, how this open standard is trying to become pervasive. Now, GIS and 3D is advancing, and we have all seen the movement that has been taking on in whether it's creating digital twins or representing geospatial infrastructure or buildings or cityscapes. All that field has been evolving in the past decade. But what is new in the last maybe 5 years is that previously, oftentimes we used to have, very high-end desktop systems. People used to model these things, but now almost everybody wants to do this on the web all the time. So the web is not just an addition, but it has become the primary interface where folks want to do modeling, visualizing, analysis of 3D content. And these capabilities, whether we're talking about being able to, model a cityscape or a network using point clouds, meshes, or procedurally modeled or ML and AI generated models, it has all come to the same place now that people expect, integrated experience, the same experience that you have in desktop, the same experience, people would like to have the same experience on the web and the mobile. And this is where, standards, open format standards such as I3S and 3D Tiles and X3D and others come into play, where the content could be generated in a variety of applications and a variety of, softwares. But if it could be shared into an open standard, then everybody can consume it. The more the merrier, right? So I3S, Index 3D Scene Layer, was one such format that was shared to the OGC, to the community actually in early 2014, and then the OGC, the Open Geospatial Consortium, adopted it as the first community standard in the fall of 2017. So we're very happy that OGC ran away with it. And, as standards go, it's a living, breathing standard. It's been evolving, and we are now on the second adoption of the I3S or update of I3S 1.2 with OGC. And ASRI has been maintaining this community standard at the community GitHub version of it down below shown. But OGC has been very instrumental in actually pushing that and making it work in all different systems. So what is I3S really? I3S has support for streaming massive amount of geospatial content. It supports 5 different types of layers: 3D objects, point scene layer, integrated mesh layer, point cloud scene layer, and building scene layer. Now, as I said, the process with OGC, how we have gone about it is, incrementally updating this format. So the first 4 layer types are currently supported as an OGC standard. Building scene layer hopefully will be upcoming soon. Again, the process takes time, and community adoption and whatnot needs to be there. So typically we stagger these things over time. But with I3S, as I said, with this different layer types, you can model your real world, with 3D objects being able to be used to model, 3D scapes, 3D cities, and integrated mesh, what we call, skin of the earth, where it has both geometry and texture mirrored into a single entity, and being able to be streamed and consumed on the on client application is also a good way of modeling, real world, as well as points symbolized by 3D models, GLTF, or any other format that you have are also a typical way of representing your 3D world. And then obviously point cloud is also another format. So this extensibility, open formatness and extensibility with new layer types and profiles allows the system to be, not antiquated, but still be mature, and but you'd still be able to add new features without worrying about breaking compatibility. So in following that pattern, a building scene layer is the new layer type that has been out for a few years, but once the momentum builds in the community, will hopefully be adapted by OGC as well. As we speak right now, actually, the OGC is about to publish the I3S 1.2 standard. So this is the second adoption, actually the third, because we had I3S 1.0, 1.1, and now 1.2. The third evolution of the format, where we improved better material support for PBR, GLTF compatible material support, paging of nodes, where we're reducing massively the client server traffic. This is akin to having implicit tiles, but the paging, the nodes are now paged into a group of nodes, so that the client server architecture would only request a a group of nodes as opposed to each tile per se. Compactness of geometry, breaker compression is now supported, where the geometry is even more compact than it was before. And additionally, one additional feature that I3S 1.2 is going to bring is the ability to support KTX2 or basis compressed texture support, and this significantly reduces the texture size that used to be shared between client-server architecture. So these are some of the updates that are upcoming with I3S 1.2, which is just under adoption with OGC right now as we speak. So let me just quickly go through some of the experiences that users would like to see with open formatness, and also being able to do it, as I said, in desktop, mobile, and browser. What are the experiences users like to see? Well, here is the first experience where being able to represent 3D content has this dual nature where in the past, maybe if you rewind 10-15 years, procedurally modeled or attribute-driven representation of cityscapes was the prominent or the major facet that you typically see. But that has now changed, right? With reality capture and being able to capture the world as it is, that has evolved, but it doesn't mean that it has been replaced. 3D features, database-driven views of your city or your landscape is also prominently important. But then at the same time, being able to marry that and merge it with reality capture content is also key. Now, analysis, not only folks who would like to just see, visualize, and hop around the world digitally, but also perform analysis. Would I be able to do typical line of sight analysis or contours being able to dynamically generate it? These are the experiences, terrain analysis, for example, is experiences users would like to see in a web application. Scenario. So here you see that, I have scenario A and scenario B. Would I be able to, this is very important in planning, in urban scenario, urban redevelopment analysis, where you'd be able to model, say, in this case, from vantage point A and scenario B, what are the line of sight visibility, Additionally, my favorite one here, how about being able to model, time change, daylight? For example, here, you'd see that, in temperate zone areas, it's very important to see how many hours during the day that a new proposed building is going to cast a shadow. And, getting an analysis of that is an important use case. Yet another use case is the ability to represent from realistic, this reality capture model to schematic, where it's driven by attribute. This is city of San Francisco. The same data, the same I3S layer is now being represented, styled in reality capture mode, schematic, and then even having fun, sort of like hand-drawn style or symbolization, artistic, if you will. So being able to do that, have different views on the same data and the same open format I3S layer is important for users. But that's not only the experience folks would like to see, right? Folks would like to model climate change and disaster response with realism included here, as you see, like, the reflection on the water is there, and the model shows a reality capture or of a cityscape where people are modeling, 100-year flood models. What would happen if, there was flooding of this lake? And then again, mirroring that was attribute or attribute-driven information overlaid on top of city captures would, give this added contextual view into your data. So these are some of the experiences that users are expecting to see. The other layer that I mentioned that is supported in I3S and hopefully soon will be adapted as part of OGC as well is building scene layer. So here we're revealing the inside of a building. If we come from cityscape, landscapes, and then go into a building and be able to reveal the content of the building itself, and not only that, be able to isolate. For example, in this case, it's isolating the stairs. That's what I'm more interested about. And I will be able to measure the exact specific stairs is an experience that, again, GIS users are asking for and is available in the context of Esri products, and also as again supported as a part of the open format I3S. Now, another area that we've been working on with I3S is I3S and deep learning, making I3S AI and deep learning friendly. So as you can see here in the upper slides, can I use I3S data to be able to, say, classify the power lines, and be able to get a good result? Yeah, you can achieve really good result, but format is structured in such a way that it is very friendly for using point cloud data for segmentation, or even further for using integrated mesh to be able to automatically segment the data to say if it is a building, a car, or a tree, be able to semantically label that automatically using deep learning models would be a great addition to the format. So again, the format supports it, promotes it, and we're using that also. One area that I would like to mention about, where we're talking about open format is leveraging open formats such as GLTF to be like to be able to use it as a glue to connect, between different disparate systems. So GLTF is supported in I3S and is used sort of to maintain consistency, not only on web platforms, but all across. Now, there are many different, applications that would generate many different formats, and then being able to bring that into a common format, in this case in GLTF, and then also be able to publish it as an I3S content would allow us to interop with various different applications, not only within the ArcGIS ecosystem, but outside also. So just a quick example of that is, being able to say, connect to some GLTF warehouse, bring it to the application, display or model an I3S point feature or point scene layer symbolized by GLTF is very powerful. Keeping the the quality and realism that comes with these models is also very engaging for your typical GIS user. So again, we try in the Esri ecosystem of application, we try to support it everywhere. Again, where all these products that you see work with in desktop, mobile, and browser ecosystems. Here is another example of that, an application that shows a citizen engagement or collaboration use case, right? So the application is trying to show that you can plant objects here and there, but then also can connect to, a GLTF warehouse and plant that object. In this case, this crane is, and the trees are GLTF models shown. Another area I3S has been used and is also very effective is, bringing geographic data, geographic content to game engines and allowing an immersive experience, right? So as we go into that world, into per se the metaverse, if you will, pervasive environments from desktop to XR to mobile are becoming more expected and standard. And for that, again, having this common open format that allows you to do that is a key feature. Actually, turn off the sound here, sorry. So here, an experience that you would see on the right and left are the ArcGIS Maps SDK that allows you to consume I3S content within a game engine environment. Now, this actually brings a huge opportunity for geospatial, where it's immersive, it's engaging, it brings a new paradigm and a new experience for users that have maybe not used that kind of a system. So being able to do that in a virtual system and able to do planning. For example, on the right, you'd see that using a head-mounted VR experience, you can do planning where you would say, well, this is the proposed zone. This is where I would like to see, city being built. and modeling it, reviewing that architectural model within, collaboratively within your colleagues would be just an amazing experience. So these are the experiences that are coming up and being supported by the format and by the ecosystem. So the ArcGIS Maps SDK is out now publicly. Anybody can download and beta try it, and it's available for both Unity and Unreal, and again supports the I3S standard as well. Then my last set of few slides would be about the I3S support in open framework. So in the past 3-4 years, we've been working with the open community and trying to make sure that I3S is supported in open formats. One good example of that is LoadersGL. LoadersGL is a part of WSGL framework that allows you to load geospatial content. So not only we were able to work with the community to support I3S within LoadersGL, but also with DigGL, where you can load the I3S content in an open format in an open FOSS viewer. And this this experience actually has brought various enriching experience from community that was not, exposed to this, and we're very grateful for that and happy that LoadersGL community has actually embarked upon that. So that's one example where I3S is being now used in an open format, open ecosystem. Another one, I'm glad I had Peter here on the call too as well. I3S, we've been also working with the community to support I3S in, say, CZM, being able to visualize an I3S there in the CZM would be really a great addition. There's an active PR for it, and the CZM repo and is undergoing the review with the team, and hopefully soon that will be also become available. But we didn't stop there. One thing that we've noticed is that having an interoperability between I3S and 3D tiles and other formats have been very key ask of the community. And because of that, we've worked again with the LoadersGL community and in providing a converter. This converter that allows you to transcode between I3S and 3D tiles and 3D tiles to I3S has been very popular and is available to generate content both ways. Both support for LoadersGL and DigGL, they're all under open source and under MIT umbrella of licenses. Anybody can use this converter or just the LoadersGL and DigGL community to be able to consume an I3S content and also generate other formats from within it. In summary, what I would say is current trend is pointing for 3D WebJS to become the primary interface for most geospatial users. A good out-of-the-box functionality. We provide a whole set of functionality from desktop, mobile to web, as well as APIs. But a good chunk of the user base would just appreciate just the features, out-of-the-box functionality, whether it's in FOSS or COD solution, and be able to consume it, without a lot of issue would be a great thing. Geospatial users expect consistency and experience of data and quality between web, desktop, and mobile experience. And this has been evident that people are not going to settle for less, whether just because it's running on a mobile or web, quality or consistency should not be compromised. But going forward, there are risks, right? Fragmentation of features between various browsers and being able also to have a content that works across all platforms is also a challenge. With that, I'll wrap up and I'll give it back to John. But if I could be entertained for like 1 minute, I would like to quickly show the examples of the I3S that I said are available, being consumed in the open format. So here is one example of I3S 1.7 being consumed in the LoadersGL experience. This is city of San Francisco with 3D object layer, 80,000 plus buildings, and also being able to support feature identity and feature segmentation. Similarly, the CZM experience of what I mentioned, being able to use the I3S content is also available. Again, where you'd be able to identify features and be able to select it and also be able to, use various types of I3S layer supported 3D objects as well as integrated mesh. So at this point, I can give it back to you, John. And
thank you, Tamara. Well, I really do appreciate both your and Peter's presentations. I think you touched on many of the elements that we wanted to focus on today, which were discussions about functionality, functions about consistency, and obviously the issues associated with standardization. So obviously I've been receiving some questions as we've come in. And Peter, the first one I'm going to direct to you. How can Cesium collaborate with Web3D about open standards and interoperability?
Yeah, so Cesium's all about open standards and work collaboration. So like we're always happy to talk about this stuff. We always we'd like to invite you to bring any insights, use cases, and stuff. I mean, like all our open source stuff is on GitHub. 3D tiles and Cesium. We're and that's part of why we're here at Web3D is just to talk about the open our commitment to open standards, and because it's super important to be able to make things that that can be shared, and make formats that many different applications can work with.
And that's a great comment to kind of build upon. I mean, Tamara, we're inherently in this conference, we've been talking about a variety of different issues associated with the evolution of the metaverse issues, looking at how geospatial content is going to continue to evolve in a web browser standpoint, and looking at the way we're starting to see things taking place. And obviously the efforts are going on OGC, the efforts going on Web3D, consortium to want to create further collaboration. How do you think Esri can work with Web3D to ensure the same thing, that same interoperability, those same issues about open standards, adaptation of formats such as X3D, as well as the other formats that you brought up in the presentation?
No, that's good. So we're actually kind of living it right now, right? Interoperability between different formats is key feature. And in fact, when I3S came out in early 2014 or so, we just made sure that it was an open format, that folks would be able to consume it in all different application codes or FOSS solution, and be able to interchange and exchange content from I3S to other formats. So that being the case, OGC has played a big role in that. The fact that OGC wanted to standardize and make the I3S format an OGC community standard was great, and was the first one adopted, as I said earlier. And I see patterns like that where be it X3D or any other formats that wants to interop with this standards, the pattern or the way that I would see forward working with this would be through open format converters, for example. Now I mentioned the 3D tiles to I3S converter that we spend a lot of time working with because we saw the need. Folks are going to have content in all different formats. But just because they have it in different format, they should not be, kind of excluded from using it from their choice of application. So how do you really bridge that gap, right? And for us, the way that we've looked at it and what we've been working on was trying to provide this open source, open format solutions. And once it takes off in the community, really that momentum will take it to many places. And I would say the same thing could happen also with X3D, be it with I3S or 3D tiles, and being able to interop with it, and by providing some converters would be a way to go about it.
Well, that's a great way of putting it. I mean, the issue here is to find ways that we're looking at, creating, I guess, a Chinese menu approach from a converter standpoint, where you understand there inherently values taking and moving from one domain to another, and how we're trying to inherently bring as much interoperability as we can to this community. From our standpoint, I mean, obviously you all have been both Cesium have been looking at the market and looking at how the market continues to evolve. From both of your standpoints, where do you think, looking at the changes in the market, where are the places that are kind of surprising you, where there are interests in the market that you hadn't really considered? Is there a place in the market you've had that you're seeing growth that you had really thought that you were seeing growth in? Peter, yeah.
Yeah. Pause. The.
If you guys don't, I mean, it's fine. I'm just trying to understand. I mean,
Yeah.
here we're talking about converting. We're talking about collaboration. The question I'm trying to understand is where there's opportunities. We see the market and the environment starting to evolve too. I mean, inherently, the idea here is we can find ways to build on all the applications that both of you presented. I'm just trying to figure out where we think we see Web3D going and how do we end up finding ways to work together to get there.
Yeah, and I mean, some I guess. Sorry, this question just caught me a little bit by surprise.
Okay.
Yeah, the like certainly we see like lots of cool technologies being used. I mean, like say for example, like see like LiDAR and photogrammetry and point clouds and stuff used a lot. For as one use case that's seems to be becoming more prevalent. I mean, think about like LiDAR is now like even on our phones and drones and whatnot.
Good points.
So like and there's plenty of other formats of data, and making these available to hey, I can like scan something on the phone and then pop it into Cesium or ArcGIS or something.
Well, and that's the question. I mean, that's a good point. I mean, inherently the applications are becoming a lot more user friendly. We're able to put, people are able to sit out there with their iPhone 13 Pro and sit there and start scanning objects they haven't inherently before. Where inherently people are going to want to find ways to capture that information efficiently into these environments. And I'm assuming you all are considering those challenges and how to bring that data to bear quickly and efficiently and using standards that are internationally recognized. And inherently that's what we're thinking about as well. I mean, do you see that continuing to evolve in those directions?
One additional point that I might like to add is I see actually even bigger opportunities going forward. And we've talked about the metaverse and whatnot, where the challenge, when we are all coming with all these different formats, different standards, and opportunities that I see is that, for example, in the areas of metadata is one thing that Peter touched upon as well. And ICRIS also has a robust support for metadata. But one thing that we could all work together in making sure semantics, that we're talking, we could be talking about the same thing, but calling it differently. And that could pose a lot of challenge. And typically organizations such as Web3D and Chronos and OGC, where they could really help is, stating that or having a platform where, those things are succinctly described and are labeled, and the community can use it similarly. Because the worst thing that could happen would be like, having the same thing being called differently because of different products, vendors, and whatnot, and not being able to interop, whether it's in the metaverse or in different applications that you are trying to use it. So those are opportunities that I see coming together and working together and making sure that we're, communicating or labeling things similarly, at least having the same kind of nomenclature would help a lot.
Yeah, and
go ahead, Peter.
Yeah, sorry. What Tim said definitely is important to us too. Is especially with the open metaverse and trying to build this interoperability. And yes, we have our metadata and schemas and stuff, and we have the intent of we have these semantics in say in 3 tiles or whatever. But yes, there's another level above that you need to have is you need to be able to have conversations, but like between players in different industries to be able to say like, hey, what is what properties do we what is actually meaningful, what can we all use, and like and standards groups, the OGC and Kronos and Web3D, like certainly like those kind of conversations are important to with them to make this happen, to because like in order to have it interoperability like requires discussion from everyone. So
well, and that's the value proposition, as Nicholas ended up indicating starting this workshop, was the thing was is that we came away with SIGGRAPH with a clear understanding that things were really evolving quickly for all of us. We were all trying to adapt to an environment that continues to change, where the power of the data and the power of the visualization are more and more integrated day to day at different levels of our culture. And from our standpoint, the need here is, I think you both have touched on, Cam's touched on a really good point with regards to the need to come, for the community to come together and come to create a foundation that we're all working from the same kind of construct and framework. I think it's important that we're in that. I think we're also realizing that if we're all going to succeed, we've got to create mechanisms, that converters and other tools that allow us to create greater interoperability between our different approaches to these type of issues, just to to create further engagement and move the forward as a whole. So I mean, if we could begin building on those type of things, I think that would be extremely exciting. I don't want to eat up. We got just a couple more minutes. Does anybody else have any questions? Nicholas, Peter, both of you are on the session. Here. No. Okay, so both Peter and Nicholas are both quiet, so I'm going to assume we're all set. Thank you all for your time today. We've got to the top of the hour. I did appreciate this discussion. I look forward to building on it going forward. Thank you all for making the time, and hey, everybody have a great day. Okay.
Thank you.
Thanks for having us.
Thank you.
So thanks to all the speakers for this interesting session. And let's wait like 5-10 minutes to have the people move in and out from the session, and then we can start the next one, which is the Web3D Town Hall. Welcome everyone to this new session. The session is Web3D Consortium Town Hall. I believe all the speakers that we had in the list are in the members, and we have spectators. So while we are waiting, after this session, there will be another occurrence of the social event. Don't miss it. And tomorrow, at the end of the day, we'll have the closing with the award for the best paper and the HNIM. We will have the flash showcase with some of the attendees showing live some of their project and the general farewell that we do at the end of the conference. So don't miss it. Is there some other in the spectators that needs to be promoted to panelist? Just write it on the chat, raise your hand, and let me know. So hello again. This is the other session of the afternoon, the Web3D Consortium Town Hall. Let's welcome our speaker.
Are you able to see my screen?
Yes.
Is it full screen?
Nope.
Hello, everyone, and welcome to Web3D Consortium's Town Hall. For those of you who don't know me, my name is Anita Havele, and I am the Executive Director of the Web3D Consortium. Thank you all for attending the conference. And most of all, thank you to the Planning Committee for working so hard to make this a very successful event. This is our annual Town Hall meeting, and we typically do this during the conference. The conference is sponsored by ACM SIGGRAPH in cooperation with the Web3D Consortium. And we are very instrumental in executing this conference along with our hosts. This is our opportunity every year to outreach to the 3D community and share all the research and technologies happening in that year. This is a time for us to share and learn. And it's a good opportunity to connect. And we were hoping this would be a face-to-face conference, but again, we are here in the virtual world, but still the attendance is pretty good. And I'm hoping that during this presentation, you will learn about our organization, our standard, and hopefully towards the end, we can have some open discussions on what our future initiatives should be and how we can all work together. So during this presentation, I was planning to co-present with our President Nicholas Paulus and our other board members, Vince Marchetti and John Coulette, and they will be showcasing some use cases. I will go over the consortium and its standard. I will also discuss the highlights for X3D 4.0 and some of the milestones that we reached in 2020 and 2021. Also some new standards, organization collaboration, so Web3D roadmap. And hopefully after the end of this presentation, you'll learn more about us and will want to engage with us. So when I started working on this presentation, I was like, should we even talk about the metaverse? But I thought it was really important for our community. The metaverse is on all our minds. It's the current hot topic. And if done right, this could be a successor to the 2D web that we have now, with functional virtual spaces instead of web pages. Now, some of us have seen quite a few metaverses come and go. And if this one has to sustain and be successful, it would be very important to really have this world really realistic and lifelike. And these virtual worlds will have to interoperate with each other and also somewhat indistinguishable from the real world. Now, there's a lot of work to be done to really make this happen. And that's where the 3D community comes in. We have a big role to play. along with the government, agencies, industry leaders, standards organization, content creators, and also users. I mean, together we'll have to work to really build an open metaverse. And we at the consortium have been working on open standards for over 20 years. And we hope that we can play a role in this metaverse and provide something that this community needs. So here we are, almost 25 years of building standards and paving the road to collaborative 3D graphics. We have two active standards, X3D and HNM. Our consortium was founded in 1997. It's open, it's an international nonprofit organization, and we develop royalty-free ISO standards for 3D on the web. We are a language, we are a presentation layer, a language to add 3D models, geospatial, imagery, AR, VR, and more into one application. You build once and you use it on multiple platforms. Our members span from government agencies, academia, research institutes, industry, practitioners, gamers, artists. So everyone is free to join. And also our standard is royalty-free for industry to use. So I want to talk a little bit about the standard and what X3D is. It's 3D, it's a scene graph, and it's a VR and AR capable. It's interoperable, extensible. Interoperable because it's based on profiles and components. So you can build your application based on your needs. It's extensible because it has multiple nodes, and some of these nodes are domain-based. So you can pick your profile and pick your application for your domain. We have collaboration, we have animation, we have humanoid animation. We have two open source implementations, X3 DOM and Excite. X3D runs on multiple devices, from phones to caves, and is being used in multiple domains. The web is our platform, and we are integrated with HTML5, GLTF, and WebGL. So here's our ecosystem. How does all this work together? So you can bring your 3D models from different authoring tools from different domains, whether it's an OBJ file, a step file, or something from 3ds Max or from MeshLab. You bring it into X3D. You can also inline GLTF, 3D assets. Then you can build your application. X3D is your presentation layer. You can add user interactivity, animation, using time, touch, space sensors, and publish this to the web. You could publish it using the web browser and using our X3 DOM and Excite and publish it to any platform on the web. So web is our platform. But if your need is a standalone system, you can use our plugin browsers and our open source implementations, and also provide your solutions on standalone systems, because there is a need for that too. So an interactive 3D presentation layers. So while the industry is providing standards at different layers, whether it's hardware accelerators, whether it is lower level graphics language, X3D is a language for web authors. It's XML based. So if you compare it to WebGL, WebGL is for graphics programmers and X3D is for web authors. So if you see, if there are 100,000 graphics programmers, we have 1 million web programmers. So this makes it easy for web programmers to bring data from multiple domains into one interactive 3D web application. So it's easier for 3D to get to the masses when you come to a web author's level versus a graphics programmer. So we have several use cases in different domains, and I will try and go through some of the examples here, and I will do it live from our website. Before we do that, I want to go over the history of our organization. So we started in 1994 with Wormhole. In 1997, WEB3D consortium was formed. And in about 3 years, we developed X3D version 3.0, which was the next version of Wormhole. Wormhole 2.0 became version 3.0. It was XML based. It was the next generation BRML. In the next few years, there were several open source implementations. These were all standalone implementations because the web was not ready for us to provide X3D without a plugin. With WebGL in 2013-2014, there were several JavaScript implementations, XVDOM and Xsite, and here we had an opportunity to provide 3D on the web without any plugins. This was a big game changer. And then in 2016, 2018, all the VR devices started coming into the market, and X3D was providing support for WebVR and also binary streaming with GLTF. And in the last couple of years, we have provided HTML and GLTF integration. We have 3D printing, 3D scanning, WebVR, AR, and this is all part of X3D 4.0. So as you can see, we are optimizing and evolving for current market needs. Again, we are going from evolution to standardization, and then adding all these new technologies to our standard. Excuse me. This is our 26th WEB3D conference, and we hope to continue for a few more years. So we are very excited to share with you X3D version 4.0. It's integrated with HTML5. It has 3D printing for models, and this is also very important because X3D provides multicolor printing and also metadata information, which some of the current 3D printing formats do not support. Then we also have the web audio. That's an interesting feature that we've added to this version. And inlining GLTF assets. That's very important, and physical-based rendering. So as you can see here, it is a pretty robust release. We have done, this release has a lot of new features compared to the last one. And we have 2 open source implementations that support all these optimized features that we have in version 4.0. It's right now submitted for ISO balance, and it should be ready by next year, Dawn. Again, these are the 2 open source implementations. You can go try them out today. And then we are integrated with HTML5, WebGL, and GLTF. So the reason it's really important for us to converge with since we are the presentation layer and all the other technologies are underlying technologies, it's important for us to track what the other standards associations are doing. At the previous session, somebody said it's so important that we be interoperable. So we have several MOUs with OGC, Kronos, HL7, ISO, W3C, where we work very closely with these organizations. We track their progress. They are also tracking our progress. We mutually meet within each other's working groups. We share information. This really helps us converge all these technologies to really build a cohesive, interoperable platform for 3D. We have domain-based working groups, X3D, humanoid, medical, and we have some new working groups. I'll be talking about that in my next slides. But this is a great opportunity for you guys. If you are interested in any of these domains, since our working groups are domain specific, you can be a part of this working group. All our development is done on consensus basis. It's vendor neutral. So there's an opportunity here for you to discuss and share your technology, and really a good opportunity to work with 3D experts. There are a lot of lessons learned here, and information is really shared between our members. So we have recent new collaborations with IEEE body processing organization, and we have worked closely with them, and we are trying to collaborate. And one of the extensions are metadata. Enabling metadata was very important for their community, and their requirements helped us define our metadata functionality. And then we are also working with the healthcare data, and we've had a couple of projects and tests that we are doing, and how to include X3D in their payload. And the healthcare industry is large. It is very, it's closed in some ways. So there is a lot of work here to be done to integrate with the healthcare community and bring 3D to their platforms. And that's one community that is lacking in that area. And I think there is a lot of opportunities for our community to engage with the healthcare standards and see how we can bring 3D into their domain. We have new members here, IBM and 3D. We are hoping they will help us evolve our standard, optimize some of our functionalities based on their business requirements. They come to us with their requirements. We share our lessons learned, and this is a good opportunity for the members and the working group leaders to share information and learn from each other. So these are the two new working groups that we have. And this morning, which was like 3 a.m. for me here, the 3D user experience had a tutorial, which was very, very interesting. And if you have some time, please watch their tutorial. And then this is an area where I think there is a lot of work to be done, especially with the metaverse. User interaction in the 3D world is going to be very important, and we would like you guys to join us and help us, help us work with our user interface experts and evolve and improve our standard. The semantic web work is also, a lot of work is being done in that working group too. I think they had a tutorial this morning or tomorrow, I think. So if you get a chance, please take a look at these tutorials and learn more about our working groups. So we also have a new marketing website. If you go to this website, there are examples. I'm going to try and go here and see what happens. Oh, wow. Oh, it did work. So you see, this is our website, and 3D is running on our website there. So if you go to this website, this is mostly for beginners. If you want to learn about X3D, we have a tutorial here. We have examples. We have resources. Let me go to one of the recent posts and so I just want to show you this. I haven't done any programming for the last 15 years. And I was able to write this little code here with some help from Vince to be able to add this 3D model into my blog here. So as you can see, this is X3D for web authors, not that difficult, and it's possible. You could probably do this in a couple of days, or less in some cases. So I think I'm back here. Okay, we had several webinars. So you can go to our webinar link here and learn about X3D browsers, X3D tools. This is a great opportunity for you to learn about this open source technology.
Anita, I'm sorry, Anita, could I interrupt, please?
Sure.
This is exciting, what you're showing us. However, your audio keeps jumping in and out, and I was having great trouble hearing your last segment here.
You guys all having problems with the sound?
Correct. Your audio is hard to hear.
Is that true for everybody?
Vince, are you experiencing that too?
Keep your head closer to the microphone, so don't move too far away from the microphone.
No, I'm pretty close to the microphone, but can you guys hear me?
I can, yes.
Okay, good. Thank you. So I'll move on to the left side. This is also another example. I just didn't want this to crash when I'm going from one program to another, but it seems to be working, and I don't know why my virus is not happy about this. So here's our homepage, and if you go to our homepage and you scan this, scroll through these images, you can go to different use cases here. And I'm going to try and go to a use case which I think will interest all of us. Probably not find it right away. Yeah, this one here. So this is a large streaming oil rig model, okay? I think over 2 million polygons. And let me just launch this and you'll see how fast it's loading here in my web browser. Hopefully, yes, not bad. Considering we have quite a few people here sharing video, and so it's loading this model. I mean, this model was built using 3D assets from different domains. And as you'll see, as it loads this model, there is animation here, there's user interaction here, there's also HTML. So you can see I am moving this model here. You can see the animation here with the helicopter. And then you see the waves moving. And with HTML, I can move the sun's position. So here I have this application that is really using, that's inlining and streaming large 3D models. It's using HTML, it has interactivity, it has animation, and it's pretty robust. So this is an example of what X3D can do. So some of you, if you're new to this technology, please go to our website. There are webinars, there are pages on how to model, how to use X3D, and please try and do that. So let me just close this. I hope I don't lose. I think I'm done with my demos. So I'm just going to go quickly through my slides and talk about a little bit about our working groups. And some of our working group chairs are here. If you guys want to just jump in and say something, Don, you may want to say as you are the chair of the X3D working group. Did you hear me, Don? Hello?
Seems like your volume is variable to me.
I can hear you guys really well. I don't know if it's your network, Don, or it's everybody's network. I hope you guys are not having this, not everyone is having this problem. Vince, can you hear me?
I can hear you. I think we should continue.
Okay. So, Don, it must be your network then if everybody else can hear me. So we have Vince here, who's the chair of the Design and Printing Working Group. Vince, if you want to say something for a minute or so.
Okay, well, just one of the activities of the Design and Printing Working Group is to liaison or have a liaison relationship with SC4, which is the ISO committee devoted to manufacturing, or I should say product data. So in the fields of manufacturing and computer-aided design, one of the things we are working on is a document, a consensus kind of standards-based document on the requirements and needs for visualization of computer-aided design. Many of you are aware that it's really been an immense explosion in the technology for 3D computer-aided design applications, both in the capability of the sort of the high-end systems, the kind of things used by your large aerospace companies, but maybe more significantly, we're seeing capability that was once, again, this sort of high-end, very expensive, being moved down or moved over to being implemented in the web browser. There's a well-known company, OnShape, out of Cambridge, Massachusetts, was offered a very full-featured computer-aided design program. This is bringing 3D design to many more commercial enterprises, and we really have to update what we think visualization, that is seeing the product among a broad audience, means. And I believe Christophe Mouton is joining us. He is leading a group on preparing that document. And WEB3D as the public standard format for visualization, we really want to be a part of that effort in bringing together people from across the computer-aided design world to, again, in a standards-based way or in an open way, come up with ideas, making visualization interoperable among several domains. And that's one of the advantages. As a member of ISO, the consortium does have that standing to participate in those kind of activities alongside your large aerospace and automobile and manufacturing enterprises.
We also have Mike McCann here, who is the chair of the Geospatial Working Group. I don't know if he's one of the panelists, Marco.
I'm trying to promote him, but he should accept the promotion.
Mike, can you accept the promotion?
I activated this microphone, so he can already speak. But, okay, he's arriving.
Oh, I guess we'll move on if Mike is not joining us.
Oh, hello? Hello there, can you hear me?
Yes, yes, yes.
Yeah, so the Geospatial Working Group, it is still in but in kind of a holding pattern right now. And But there's, really lots of interesting issues to work with in geospatial data, as Cameron, so ably demonstrated in his presentation. The challenge is just to kind of standardize a lot of these client server needs for level of detail management and those sorts of use cases. So really looking forward for more participation in the standards development in that client server world. And I'm optimistic that we'll get there and have many implementations to choose from for customers that have their own server side resources and they want to use all the richness of X3D to visualize their data. That's kind of all I have to say about that effort.
Thank you, Mike. Thank you, Mike. So I'm going to go to the next slide here. So here are some highlights from 2020 and 2021. Our members, NIH and NPS, are providing helpful 3D printing resources during this crisis. And we were working diligently on X3D version 4.0. And then we had a couple of speaking engagements in late 2019 before the pandemic started. So we are continuing to engage with different communities to promote our standard, to converge with other standards, and to learn about their requirements too. So 2021 events, these are some of the 2020 and 2021 events. So we try and we always go to SIGGRAPH, and then we have the Web3D conference, and our members go to other conferences, and that's how we try to outreach and engage with the different domains within the 3D world. Webinars, of course, there's again, we call ourselves as a presentation layer. We are above WebGL, we inline X3 GLTF, and here you bring assets from different 3D sources and build your application. So our standardization process is pretty straightforward. Our working groups work with the X3D working group, and then we go to ISO for ratification while working with other standards bodies. And when our standards are ready, our members get early access, then it goes to the government, the community, industry, and finally adoption. We have several SDO partnerships going on. Our biggest one with this ISO, since our standard is ISO ratified. We work with SC24, Working Group 6, X3D, and then we also are working on the mixed augmented reality reference model. We work with OGC, CityGML, and other 3D cross technologies where we can converge, and they need our technology, we need theirs. We work with W3C, of course, Chronos, WebGL, GLTF, IEEE, 3DBP, and HL7. So as you see that we are not just in our own bubble developing our own standards, we try and see what the industry trends are and work together to evolve and promote our standard. There are several benefits to the Web3D members. There are many market opportunities, business opportunities. Again, you can drive the standards, you can lead the working groups, you get early access, you can be on the board. There are networking opportunities like this conference, and many other. We have other opportunities where you can meet with our members and other industry leaders. So we do have a talent bank where we have experts and who you can share your knowledge, and they share their knowledge with you. So it's a pretty, it's a community that is very open, willing to help. And I've been with them for a few years, and I can tell you that when there's a problem and somebody calls me and says, hey, Anita, I'm having this issue. Who do you think I should talk to? I call one of my members and they're ready to help. So join us and help us build this standard together. So there are many resources here for you guys to learn about X3D, and these are all on the website. I will be sharing this presentation, and Marco, if my audio was bad, I will re-record this presentation and send it to you. This is the roadmap, and I was hoping Nicholas would talk to this slide set, but here's something I think we would like to share with you guys. These are some of the milestones for 2020, 2021, and we also have some initiatives that we hope to accomplish in 2022 and 2023. So for one of the things we're working on is the VR, AR, MAR initiative, which is going to be part of X3D 4.0, 4.1. And we are really looking for members who are interested in working with us in this domain. I know with the Metaverse, this is going to be very important for us. We do have WebXR support. We are working on we do have Web VR support. We are working on WebXR support. So we will be supporting the web technologies, but within our standard also there is some work to be done. And we are looking for partners to help us evolve and optimize our standard. We have several new marketing initiatives, a new marketing website, educational webinars, blogs. We'll continue our webinars in 2020 and 2021 and 2022. We plan to start continue our hackathons next year if travel is permissible, and continue working with the standards development organizations. So the discussions that I would like, and we have our leaders here today also, is how can we improve our support to the 3D community? That is a question to you. And what is the single biggest problem you face with the making or publishing 3D? How hard it has been to solve this problem? I just put some questions out there so we can start thinking about these things and hopefully not have answers, but have a discussion on how to solve these problems. So if you guys want to continue with this discussion, we can stop here and take some questions. And all the Web3D members, please feel free to answer. I am looking at the chat here. Marco, do you have any from the Whova platform?
Don't think so. Okay.
Oh, nobody has any questions? So please join Web3D and participate. If you have...
Is everybody out there? Is everything...
Yes, Don, we are doing okay.
Yeah, Anita, if I'm coming through, I have a question.
You're breaking up, Don.
Anita,
Maybe
your presentation was fantastic. I was able to hear most of it. Is there anything you wanted me to share with the community regarding IVN at this point, or
yes,
or not?
yes. If you would like to, yes.
Okay, perhaps against my my nature. My name is Bill Benman. I'm the CEO of Integrated Virtual Networks, IVN. We've been working for many years to bring live streaming avatars to virtual worlds. We have the technology, it's patented, it's working. We are looking to launch soon. We're looking to work with the consortium to support multiple platforms, multiple technologies. I commend the consortium for all the good work you've done to this point, as laid out so well by Anita in her presentation. But Anita, Don, Mike, Vincent, and others have done fantastic work on our behalf, and I think someday that's going to be recognized on a large scale. From our perspective, the consortium will be very instrumental in helping us to provide a solution. Initially, we were planning to build our own metaverse and just offer our live streaming technology within our own metaverse called the Nexus. But it occurs to us that it might be useful to make that technology available to others. But in the main, what our technology does is it allows you to have the experience of a Zoom call inside a virtual world, such that you can, through your navigation, through your position, through your line of sight, you'll be able to interact in an impromptu way with other people in the environment as though you were physically present in that environment. Most recently, we also received allowance of our patent application on our technology for enabling you to do that in augmented reality as well, such that with an appropriate pair of glasses, Apple Glass or whatever, you'll be able to see someone in your actual environment as if they were physically present. And they will be able to navigate around within your environment as well, your real world environment, which I think is pretty interesting. So that's what we're looking to bring to the table. We're hoping to launch next year. We are in discussions with a number of major players that have expressed interest in having access to our technology for their purposes as well. And fingers crossed, we'll be able to do that. But through the consortium, if you want more information about what we're doing, we'd be happy to answer any questions. And I'm available here and now to answer any questions that any of you may have regarding our technology called Silhouette.
Do you want to put the link there?
Very quiet room. Not seeing any questions on chat, so I think we're good.
Yep.
I should also point out that we are hiring developers. So if you have expertise in X3D and some of the other technologies, let us know.
Thank you, Bill. Thank you. Bill just joined the consortium recently, and he is he's looking forward to using open standards for his solutions, which is very important for us, especially when the metaverse.
Are you still muted, Anita?
I'm muted?
Nope. You're loud and clear.
Can anybody hear Anita?
Yes, we can.
So is it you guys in California that's having this problem, Bill and Don? I heard there's there's some weather issues there. I hear that everyone can hear me, which is good. So we'll go to the next part of the presentation where we'll have Vince, if you can start.
Okay. Anita, I would ask, out of respect for the other, you know, we are starting to impinge into the wonderful social hour or social event, I believe. And I think we should ask the organizers what they wish us to do at this time.
How long is your presentation? 5 minutes?
Okay, Anita, I will ask the organizers what they wish us to do at this time.
Gone a few minutes, and well, I think we can have like 7:15, 7:20 is fine for us. Please go on.
Okay, well, I just have a fairly quick demonstration. And I need to share my screen. That's correct.
And I'll stop sharing.
Yes. Okay, I believe I'm sharing a screen that's showing two heads. Could someone confirm that I'm sharing the correct screen, please?
Yep.
Oh, thank you. Okay, this is a little project I did after viewing an article, a journal article in Nature magazine. It was an anthropology article, and they were discussing some efforts in understanding human evolution based on scans and processing of human skull remains. This is one of the case studies visible on the WEB3D.org website, so you can follow that link to get there. And in fact, I think I can put the actual link to the web page in our chat window right now. And one of the, and in the growing trend, they actually did publish their 3D scan data not as a digital supplement. So I was able to get their 3D scan data. It was in the PLY format. And what I was interested in doing was in a 3D visualization, that is a computer environment, reproduce something that I believe anatomists do. That is, people who are experienced in studying anatomy. They were able to take two similar specimens and compare them, holding them in their hand and turning them around and just do comparisons in real time with the real object, because the human eye and human brain is actually much better at detecting differences than any algorithm you can implement numerically. So I was able to turn those scan data into X3D models. And in order to reproduce that idea of holding it in your hand, but looking at both of them at the same time, I was able to develop a navigation method where by dragging one skull, you drag the other skull in the same way. So, for example, by taking the two scans and holding them that way, you can see that there is a distinct difference in the profile of the skulls. And the anatomists have a very specific name for this kind of profile, the side and the difference there. Similarly, differences in the shape in the eye sockets and in the jaw. I am not an anatomist myself, so I refer you to the article to discuss the implications of their work. The point that I want to make is having X3D as an open standard in which the behavior of the navigation is very well documented and is extensible. And that's the important part, is that I was able to extend it with this feature of when you drag one object, the other object drags the same way. And I was able to do this completely in the framework of existing X3D standard. It was as if I had to create some extra plugin that I had to distribute as Java code. This file that this is distributed in is a standard X3D file, again, operable on any X3D viewer. And so I would hope that exposes the power of this open standard. And I just as a final thought, I was listening to the paper session this morning, and Dr. Polis also discussed the navigation behavior, some changes they made to aid virtual field trips. So again, this is the idea that having an open extensible standard is important for continuous or continued development of this visualization. So Anita, with that, I'll answer questions or turn it back to you.
Let's wait for a few questions, and then John is our next presenter. Is John here as a panelist?
Yes, John's here.
Okay.
So I don't think I can do much to add to what Vincent obviously touched on, and as well as some of the discussions. Inherently, in order due to time constraints, inherently the challenges that we're all facing is that how we bring extensible, working it to provide data in a way that has value to a broad audience. And that's seen here that you're looking at. What we've ended up doing is we try to take this and push it out to some boundaries. You're looking at 4.4 million acres of digital elevation model for American Samoa. In this case, we didn't use a lot of disparate data sets. There are other examples that have been presented in the conference where you could see that we ended up pulling together data from as many as 19 different disparate data sources. But the challenge that we're trying to deal with is dealing with some of the issues that Mike touched on earlier with regards to standards. How do we end up improving, maintaining geospatial accuracy when we're starting to push to these type of large models that inherently are really starting to really push some of the boundaries. And where we're finding is, as Vince indicated, is whether it's working with skulls or working with these large data sets, we're finding that X3D is robust enough to really assist us in addressing a variety of different issues. And I'm going to go ahead and end there. Okay, Anita?
Oh, that was quick. So thank you both of you for, showing your use cases. That's what we do usually during a town hall meeting is we ask our members if anyone would like to come and show their use cases. And here you saw two very important use cases, one from the medical domain and one from the geospatial domain. So as you can see, X3D is being used to solve serious problems. So, we call it 3D for the serious domain. So, if you have some time, take a look at our technology, come and join us. Some of our working groups are open. Just send me an email if you'd like to discuss or if you just want to watch. Give me a call, send me an email, join our working groups, come to our conferences, and get in touch with us anytime.
Anita,
Yes.
do we have another minute left for Christophe and the nuclear domain? That seems
Yes,
very
yes,
important.
yes.
Yes, so thank you very much. I'm very sorry I've prepared the last hour of my presentation, so that's why it's the last minute.
Christophe didn't get back to me. Okay, Christophe, go ahead. I didn't know you were
Thank you very much. So I will be very quick because as you know, it's something that I'm very focused for this last decade. So very briefly, it's how we try to open all our 3D data sets for nuclear power plant engineering. So I will very quickly enter the domain. So my company is a national French power utility, and we are operating 56 nuclear reactors in France. And something that I will quickly just share with you is the French President Emmanuel Macron has announced that France will restart the construction of new nuclear reactors to respect COP26 objectives about decarbonized energy. So it's a huge news for my company to know that France really built new nuclear reactors in the next decade. So the challenge, it's more or less what we discussed in 2012. So it's not a new challenge, but it's a huge one. So we discussed that with David Kasich from Bosing. It was our keynote speaker at this time, and he was dealing with billions of data and how the digital mockup and now the digital twin could deal with all this data in 1D, 2D, and even in 3D. So he mentioned the Rosetta Stone for all this data. So it was very inspiring for me because when we were dealing with engineering data and documents for nuclear power plants, you can imagine that we are reaching the millions of different data and documents. And I won't say it's difficult. It's something very tricky to manage. It's the tricky aspect, the complexity to manage. So what we discovered is that we have our kind of Rosetta Stone. So in fact, all our equipment have a code name, and this code name could help to link all the information together to be able to propose new interface to our engineers. So Rosetta Stone or digital twin, yes, I let you choose the right term. So how we deal with that? In fact, our first challenge was how to get the first obstacle, which was the proprietary format of our CAD system. So our first work was to move to an open standard, and we chose X3D at this time. As you can see here, we are using X3DOM, the polyfill, to display this small room, I would say, with a few equipment. The second challenge was how we scale, because here you have the French new nuclear reactors that we are finishing here in France, and the small dot, the small yellow dot, in fact, it's representing this small room. So in fact, we have to scale by at minimum 200, and it's really a massive digital mockup. So we started to study with some WEB3D consortium partners. So here it's Fraunhofer and Hochschule Fulda. We started to how to manage our data, how to describe them with X3D so that we can display them in X3DOM. So it was our first work in 2014. We continue in 2015 with Instant 3D Hub, a new product by the Fraunhofer IDD Institute in Germany. And I will say we reached in 2016 very, very interesting results. We were able to use a web portal which linked all our data, and especially thanks to the technology from Fraunhofer, but also to a graph database that helps us to index all our data. So now, what is the current state of our work here at EDF? So now we have an in-house solution using commercial WEB3D visualization as a service solution. So you recognize more or less the previous figure, but it's powered by a new company. So 3D, it's a company that was founded by some researcher from Fraunhofer IDD Institute. So they joined the WEB3D consortium very recently. So it's very nice to have them on board. And something that I would like to share is that you can use this in-house solution with this visualization as a service solution from 3D for a lot of engineering use cases. So forgive me to not sharing all our know-how on that topic, but yes, it's very, very impressive. And even for trade show. So what is very impressive is that we can use this kind of solution on the booth at EDF, the booth that EDF will presented in the World Nuclear Exhibition in Paris end of November. So if you're coming to Paris and if you're a specialist in nuclear, I think you will visit this booth. Thank you very much.
Thank you, Chris. Thank you, Chris. As you can see, this is a very important use case for us. And Fraunhofer has been very instrumental in providing this solution to EDF. And we thank you, Christoph, for showcasing this use case. As I said earlier, X3D is being used to solve serious enterprise problems for serious enterprise visualization. So if you please join us, help us evolve, optimize this technology for the next generation 3D web. So we have one last thing before we take off, Marco. Every year we present an award.
We are running quite late.
2 minutes. Can you bring Michaelis in? Michaelis, as a panelist.
I'm not sure. Oh, hello. Does it work? Hello.
Hi, Michaelis.
Hi. Hello. Can you hear me?
So, Don, can you hear us, Don?
Wait.
So typically we, award this, we give this award in person, Michaelis, but since we are doing this virtually, I thought we would do this virtually and present you this award in recognition of your outstanding contribution to the X3D standards. We appreciate all your hard work towards X3D 4.0. And as I mentioned, because he's a member of our consortium, he can now join the Kronos working group for GLTF because we have membership sharing. So he is a liaison between Kronos and Web3D. So there is information being shared between both organizations. And Michaelis has been very, how should I say? He's very thorough about whose functionality works and whose doesn't. And he's not shy about it. So he comes back and says, this is what that needs to be changed in X3D if we need to work with GLTF. So that has been very helpful for us, Michaelis, and continue this, this excellent work that you're doing. Do you want to say something about your product, View 3D Scene and Castle Engine? Just a couple of lines.
Okay, just I guess a very quick. First of all, thank you very much. I'm very sorry. I'm kind of from my phone, so I'm not on my desktop. I wasn't prepared, but thank you very much. This sounds. I'm surprised. Thank you very much, really. About basically my product, what I'm doing is Castle Game Engine and View 3D Scene, which is kind of it was a game engine, a game engine that you have editor for, and our strong focus is to use open standards for our models, which means X3D and GLTF. We're kind of playing both hands. I mean, I kind of believe in both of these formats right now. Both X3D and GLTF have a lot of strengths, and they can be kind of connected in a way, which is actually what we already did in X3D version 4, and I guess you were talking about it already on this conference a lot. So yeah, so it's a game engine that wants to support open formats with a special focus on X3D and GLTF, and I'm enjoying it because it means that I kind of want to have a perfect support for both of these formats. And yeah, I'm not prepared to do any actual presentation. Just Google Castle Game Engine if anyone wants. But I hope it works nicely. And thank you very much for your recognition. This sounds great. It was great. Thank you.
You can put the link in the chat.
I will. Yes.
Okay.
Thank you very much.
Thank you, Marco, and sorry for taking extra time here. And we will join the social event now.
Hello, can you hear me?
Yes, I can hear you. I can see you. What is the social event about?
Okay. You'll see in a second. Okay. There you are. Okay, can you see my screen? Yes? Okay. So let's see what the social event is about. This is dinner, so meet you at 8. If you are an organizer, local, you know who you are. Let's make it at 30 because it's late. But for the rest, what you expect from a social event, I will give a super quick introduction. You usually expect food and drink, get away from the conference, relax, stretch your legs, and engage with new people, view new things possibly, or learn something new. But which one of these things can you do virtually? It's very hard to do food and drink. It's pretty difficult to stretch your leg. You can have solution like the yoga class mentioned there, but would you do that really? And so we concentrated on the other 3 things that are doable. And our solution was to design a virtual tour. Now, a virtual tour is not particularly new. So we had a look to the other conference, how they did it. And usually there are variants of 2 things, or pre-recorded videos of a tour with a subjective view on a real guide, and which is essentially content. So it's something I can download it later. It doesn't need to be, it doesn't engage. It's just something that I can download from other sources, like I can watch on Netflix, probably will be better. Or we have seen real talk with slides and question and answers at the end, but it's just the same version, slightly boring. And there are the technical difficulties that we are all experience when streaming videos and stuff. So our way is to replicate the functional part of a guided tour. Means that allow you to listen to the guy who shows you things. You can make questions, so please make questions during this tour while the tour is going, and you can go on your own, leave the group for a while, then get back to the guide. So please meet Guido, this is the name, which is a web app, which is pretty much like what you already see with, for example, Google Street, if someone else was holding your mouse. So you can just sit back and watch what the guide is doing, or you can go on your own, and when you want to go back, you click on this umbrella, you are brought back to what the guide is showing. You can jump to places with this list, clicking here. You can hide this menu by clicking this place here, this menu icon. And you can, of course, like in Google Street, click on the tooltip to go around on your own again. And to do this, with just a quick thing, you need this technology, rubber bands to strap a camera on a helmet, people going around like this, and good developer to make all the system work. And of course, a tour guide, which should be here with us. Antonella, welcome. Hello, hi. And I will now show you 1 second how it works. She's already leading, so I will just show how to go around a little bit, and then I will leave it you with Antonella. So here we are in front of Murales. I'll go another place. See, you can go around, click on the tooltip, move, okay, and or jump to places, okay. So I'll follow the guide again. So I'm clicking the umbrella and going back where Antonella is, which is here. So we are not streaming this, so you have to click on this address that I'm going to show in a second, but it's also in the chat. It will appear. So to this one, HTTP, not HTTPS, but you can trust us. We already know we have everything we need from you. So www.guidoitalia.it is in the Zoom chat. Please do click it now and see you there. And do not leave the webinar because the audio is going through the webinar. So leave the webinar there. You will listen to the guy. You will be able to talk. If you want to make question, raise your hand. We will let you talk. And have a nice tour. Antonella. I can hear Antonella. You should unmute.
Okay, it was still
Okay.
Okay, it was a long speech. So thank you very much for staying here. I'm Antonella. My name is Antonella. I'm a local guide, and I'm very, very happy to host you, to guide you in this virtual tour. Well, it's a very bizarre experience for a tourist guide, this online experience. I really hope you will enjoy it. I really do. I really do. Okay, so I will switch my camera off because in this way my connection will be just a little better. So you will hear me, but you won't see my big face here. Okay, so let's go. Now, we start. Our meeting point today is in a beautiful part of the city of Pisa. Well, the tour is in Pisa, because Pisa is one of the most beautiful cities in Tuscany, is really well known because of its monument, buildings, history, art, and so on. Pisa is absolutely known because of Piazza dei Miracoli, a miracle square, the square of the cathedral, the Leaning Tower, and so on. But Pisa is not only Piazza dei Miracoli, it's also well, a mix of modern, contemporary art, ancient art, and so on. So that's why I'm very happy to start this tour. This is our meeting point. It's a big murale made by Keith Haring in 1989. It was the idea of a student from Pisa who was visiting New York, and he met Keith Haring, and so he asked him, he invited him to paint a big murale on one of the walls of the Church of Sant'Antonio Abate, close to the central station of Pisa, in an area that had been completely destroyed by the bombs during at the end of August 1943. And so the wall of the church was changed into a masterpiece, a very big work of art. This is one of the few, very few permanent works of Keith Haring, and it's pretty big. It's 10 meters per 18 meters for a surface of 180 square meters. It's full of colors. It's like a puzzle with a lot of pieces staying together in a strange, in a bizarre composition. But the message of Keith Haring was agreed with the student from Pisa, was very simple and moving, was about peace and harmony. The title of this work of art is Tutto Mondo, all the world together is more or less the translation. And as I told you, there are a lot of symbols that are very frequent and common in the art of Keith Haring. For example, if we look at the top of the building, we see a strange symbol, a scissor made of two men. It's a symbol of solidarity because these two men are cutting a snake, and the snake was eating a man, and the snake all over the ages is a symbol of evil. So in this way, two men together cut the evil, and so in the shape of a snake. Another incredible and beautiful symbol is this one. It's a woman with a child in her arms. She's the symbol of maternity. Then on this side we see a man, half man and half bird, half dolphin, half man. There is a monkey here. This is the relationship between mankind and nature. And again, in the center of the painting, in the center of the murale, there is a man with his head changed into a monitor, into a television. So probably it is the relationship between mankind and technology. Then there is another important symbol. It's something like an homage to Pisa. Pisa, the symbol of Pisa, the symbol of the city of Pisa in the century has been a cross with some balls, we will see it later, some balls at the end of the branches. And here, this cross has been changed into a human cross with arms and head. So the balls of the cross are changed into the head of this man. So this is in the very central area of the city, as you can see, very close to the station, very close to some coffee houses and so on. And so usually we leave this area to go to the very heart of the city, that's to say the more ancient part of the city. We will go to see the Arno River. The Arno River has been part of the fortune, of the chance of Pisa, is coming from Florence. It's a very long river. It is more or less 240 kilometers coming from the Apennines, that's to say the central mountains of Italy, the mountains that divide Italy into two parts, and is going to the Tyrrhenian Sea. So it's a strange way, it's a bizarre thing, that's to say the River Arno is connecting two big cities like Florence and Pisa that has always been fighting each against the other, and at the end Florence conquered Pisa. Pisa was founded by the Etruscans in the 8th century before Christ, and the name Pisa was probably given by the Etruscans. When the Romans arrived in this area in the 2nd century before Christ, they simply rebuilt a small city with all the typical features of a Roman city, that's to say the forum, the walls, street crossing perpendicularly, and so on. And Pisa was a very good friend of Rome. And let's go closer. But the biggest chance that Pisa had was using the River Arno till the harbor. Pisa was very close to the sea, to the coast, and the River Arno was really a good way to reach the sea. So small boats, bigger boats were used to cross, to travel on the river. And also the Romans understood the possibility of the river of Pisa. So it was during the Middle Ages, that's to say around the year 1000, that Pisa became one of the most important cities in Italy. It was one of the so-called sea republics, that's to say the cities in Italy that were the most powerful cities in traveling the sea, in crossing the seas with the fleets and so on. So the city had the possibility to gain a lot of money, to win a lot of money, because they were always fighting against other cities like Palermo in Sicily, like Genoa, and so on. So many times Pisa was victorious against these cities and arrived back home with a lot of money, with a lot of spoil of war and so on. So had the possibility to pay artists to build very important buildings. The most important buildings in the Middle Ages usually were churches. And in front of us, we have an example of a very little and beautiful church built along the river. It was important to have a church along the river because there were many warehouses along the river. So it was an habit, a very common habit, to go to the church before going to work. Santa Maria della Spina, this is the name of the little church. The translation can be Saint Mary, the Virgin of the Thorn. The thorn was a relic that was kept inside the church. And the church was built at the beginning of the 13th century in a style that we call Pisano Gothic Pisano, and because it was a Pisan interpretation of Gothic. As Pisa was an harbor, there were a lot of people arriving here from any spot of the world, Europe, of course, Europe, North Africa, south of Italy, north of Italy, and so on. So they merged they melted, and they built, well, they created something new, something original. That's the Pisan style. The church, the facade of the church, has a very, well, we can say, simple decoration, 2 gates, 2 entrances, and between the 2 entrances, there is a tabernacle with a statue that is representing the Virgin with the child, the Virgin with the child. So the church is dedicated to the Virgin. So of course, in the tabernacle, there is the Virgin. On the side of the church, if we take a look at the side of the church, we can see more and more decoration in Gothic style. So, for example, all these slender columns, 3 mullioned arches, quadrifora, that's to say, the wind of seer, they are called quadrifora because they were divided into 4 areas. Then there is also a trifora because it's divided into 3 areas. Then we have cusps, spires, and Gothic decoration. These are the 12 apostles, and in the center there is the statue of Jesus Christ. So this is an example of a very interesting Gothic architecture. Then we go to another location, Piazza dei Cavalieri, the Knights Square. It's one of the most important, the biggest square in the city, and we are on the way to the Piazza dei Miracoli. And the square is surrounded by buildings. The most important one is this one that you can see at the back of the statue. The statue is dedicated to the Grand Duke Cosimo I from the Medici family, because the 2 big enemies, Pisa and Florence, fought. And at the end, Florence conquered Pisa at the end of the 15th century. So Cosimo the first Grand Duke of Tuscany was the new owner of the city of Pisa. And of course, the Medici family tried to destroy the identity of the Pisan city, the Pisan inhabitants. And this was made also changing the buildings in the square. So, for example, this building that was the Palazzo della Carovana, the Caravan Palace, and was used for political purposes, was changed into a new building, and it was called, well, Palazzo dei Medici. So it was decorated, you can see here, with bursts, with frescoes, all on the facade. And the fresco and the bust, they celebrate the members of the Medici family. Another beautiful building is the Church of Santo Stefano, St. Stephen Church. It is dedicated to the Order of the Knights of Santo Stefano, a new order created by the family Medici, because they wanted to involve the male member of the richest family of the city of Pisa in new tasks. That's to say, for example, to protect the coast from invaders. You can see in a lot of places visiting Pisa that there is a coat of arms with some balls. The balls are the symbol of the family Medici. So, for example, here, crowned with a crown, and on the top of the building, there is a cross. That's the cross, not the cross of Pisa, but it's the cross of the Order of the Knights of Santo Stefano. The church was completely remade to change a Middle Ages church into a Renaissance church. And the architect Giorgio Vasari was the one who planned the church, So you can still see here, for example, on the side of the main building, an example of a Middle Ages architecture. You can see the arch of the tower, because at the corner of the building there was a tower to protect the building itself. Another interesting building is this one in front of us. It is composed by 2 towers, this one and this one, connected by we can say a gallery with a clock. This gallery was built in the 17th century to connect the two buildings, the two towers. This one is very interesting. It's very famous. It's called Torre della Muta, the Mole Tower, because it was said that the eagles owned by the city of Pisa were kept inside the tower in the period they changed the feathers. Well, why eagles around in the city, walking in the city? Somebody can guess about that. They were the symbol of the German Empire. So as Pisa was a very good friend of the emperors in Germany, Federico Barbarossa, and so on, they used to keep some eagles in the city as a symbol of loyalty, as a symbol of the alliance, and so on. But and the eagles, they had the feather cut, because in this way they couldn't fly away. The tower, this tower, is also famous because at the end of the 13th century, a count, a very important man in the history of Pisa, was imprisoned. It was Conte Ugolino della Gherardesca. The keys of the prison were thrown in the River Arno in order to not to permit to the Conte Ugolino and his family to leave the tower. And the family, well, they all were left in the tower till starvation. It is a very important event, also explained by Dante Alighieri in his comedy. Here you can still see the cross, the symbol of the order of the Knight of Santo Stefano. Then we leave the square and we go to have a look of the most interesting area of Pisa, the must-see of Pisa. So everybody coming to Pisa, they have to stop in Piazza dei Miracoli. We are under the entrance, there is an arch, and opened by the family Medici after they conquered Pisa. And from this gate, we can get inside the piazza. Piazza dei Miracoli, Miracle Square, or Field of Miracle. It was nicknamed by the French architect Le Corbusier as the Acropolis because of the quantity of marble used to build the buildings. We have many important buildings like the cathedral, the baptistry, the tower, that's a bell tower, and finally a graveyard, all covered with marble. Then there is also an hospital in this area. Nowadays it's a museum. And so when Gabriele D'Annunzio, that's to say, one of the most important writers in Italy at the beginning of the 20th century, when he visited Pisa, he said that this was a field of miracles because the path, the route of human life, human existence was here, from the childbirth till the hospital, disease or something else, and the baptistry, of course, to receive the baptism, and the graveyard. So the life of man, life of mankind was here, all in one field. The most important building, probably the most known building, is the Leaning Tower, of course. Take a look at the Leaning Tower and the shape of the Leaning Tower. Can you see it's just a little, it's curving a little, well, it's inclinated, of course, it's leaning, but the shape is like, we can say it like a banana. So this is due to the different stages in building the tower. But let's go step by step. The first building to be built was the cathedral. Let's go to have a look at the cathedral. So this is not the cathedral. Let's go just a moment to the cathedral. Okay. Okay, let's go here. Hopla. Let's try to have a smaller picture. Okay, So what we are looking at now is the main gate of the cathedral. Take a look at the facade. The facade is something amazing. We used to call it a wedding cake because of the white decoration. White marble is the most used marble in this building, but you can see there are a lot of different stones in different colors: red, gray, brown, black, yellow, and so on. The majority of this color of marble, and also the white marble, is coming from the surrounding of Pisa. Pisa, Lucca, these cities, they have a lot of quarries, marble quarries. So it's not, I'm sorry, it's not Carrara marble. Carrara marble was too expensive, and Carrara was really far from Pisa, more than 60 kilometers. So it was better and cheaper to get the marble from the surroundings. You can also see that there are some columns here in different color. Let's have a look at them. Here, they are red. It is said that after a big battle against the Balearic Islands, Pisa won the battle, and the spoil included also columns in red marble. That's not so frequent in this area. The gates are, we can say, modern, because they were made at the end of the 16th century instead of the three more ancient gates made in the 11th century. They were remade because there was a big fire in the church at the end of the 16th century, destroying the gates that were in bronze and the roof. And everything was remade and paid by the family Medici, that was the owner of the city, of course. Then, in front of the cathedral, we have another beautiful building, the second building to be built. The church was started in 1063. The baptistry was started in 1153. And it's the place for baptism, of course. It is in the same style, Romanesque Pisano, with a lot of new, we can say, influences. For example, Gothic, but not only Gothic. This area was, I told you, there were a lot of people arriving from the north of Africa, bringing with them new ideas, new style, and new project and new decoration. So, for example, the lines, the bands in different color are pretty typical of in Tuscany, and they are arriving from the Arab culture. Let's go closer. So, the baptistry, you can see it's more or less 50 meters high, more or less as the cathedral, and the same height is for the bell tower. You can see there is a big gate in bronze. On the gate, there is a decorated lintel representing some moments in the life of St. John the Baptist. Decoration, floral decoration on the columns at the side of the entrance. And, well, it's not easy to see, but trust me, there is a column, this one, decorated with a calendar. Once you come to Pisa, you can touch with your hand the calendar of Pisa. So it was very important because this was a connection between the church and the people living usually in the farm. Then let's go again at the gate to have a sight of the square itself. So the first building was the cathedral. The second one, the baptistry. The third one was the bell tower. It was started in 1173. So in more or less in the same period of the baptistry. They started, the architect, Bonanno Pisano, started to build the first 4 orders of the tower. And so you see the tower, later we will go closer. The 4 orders of the tower, the 4 floors of the tower. And the tower started to inclinate because of the composition of the soil. Pisa was founded on between 2 rivers, the Arno River and the Serchio River. So there is a lot of water in the soil. There is a lot of clay, and so the soil is very weak. And the weight of the 4 order of the tower started to compress the soil, and the tower started to inclinate. So the works were stopped, but probably they stopped the work because of political problems. The end of the 12th century was a very complicated moment for Pisa. Few years at the end of this century, Pisa will be defeated by Genoa, and its decline will start. Oh well, the works were stopped for 1 century more or less, and it was really the chance of the tower, because when they went back to build the 3 orders here on the top of the previous ones, the weight of the tower had compressed the soil, and so they could work just a little more safely. And I told you the shape of the tower is like a banana, it's curving, because they tried to compensate the inclination, building the 3 orders, the 3 upper orders, but it didn't work. So the tower went on inclinating, and the works were stopped again for political problems. Florence was arriving, so Pisa was in a very complicated situation. So after a century, when they started again to work at the tower, to put the belfry, that's to say the topping of the tower with the bells, the tower had compressed the soil, and the belfry was put in a way that's very different from the inclination of the tower, because they were trying to compensate the inclination. So that's why we say that the shape of the tower is a banana. Then let's go closer. Let's go closer to the wall, to the tower. So this is, well, it doesn't lean, no, it's leaning. You can see in the catino, that's to say the base of the tower, the difference between this side, the south side, and the north side. The tower is leaning to south, and in the south area there are some buildings, and they were very cheap in the past. But nowadays the tower has been fixed, there has been stabilized. So these buildings are really expensive now, of course, because they are in Piazza dei Miracoli. So let's have a look at the decoration, still in Romanesque Pisano, with a lot of columns, capital, round arches, columns, capital, round arches, loggias, and so on. So it's really amazing. It's really amazing because of the coherence of the style all around the square, notwithstanding it was built along 3 centuries. The tower is 56 meters high, and there are 297 steps to reach the top. It's possible to reach the top only by stairs, because there are no elevators inside, of course, but it's not so bad. It's really an experience, once in a lifetime, climbing the steps to the top of the tower. It's really an experience. Well, I told you that the tower has been stabilized because at the end of the 20th century, an international committee started to find a solution, to gather to find a solution to the inclination of the tower, because it reached an offset of more than 5 meters and an inclination of more than 5 degrees. So it was very, very close to collapse. And nowadays, after all these works that involved a lot of engineers, a lot of architects, the inclination is more or less 4 degrees, and the offset is more or less 3 meters and a half. So it will be well fixed for some centuries. These works were very complicated because they had to preserve the integrity of the building. They had to preserve the materials of the building and also the trace of time, the history, the evidences of the passage of the time of the ages in the, let's go just a little bit further. And so it has been a very hard work. It started putting tons of lead in the north area of. Oh, sorry. Yep. Let's go back. In the north area of the tower, and in order to compensate the inclination to south, then there were excavation in the soil of the tower, and they extracted about 38 cubic meters, so not so much soil, but the weight of the tower compressed this area, and the inclination was reduced. Then there was also a safety system just in order to keep the tower together in case of collapse. At the back of this building, there were the so-called anchor block. We will see them later. And there were ropes, cables in iron and steel, keeping the tower together just in case of collapse. But well, they didn't work. That's to say, they never entered in action, and because the wars went well. The last work was to make a system of drainage, because the worst problem of the tower was the rainfall. Rainfall infiltrating in the soil, making the soil weaker and weaker. So this is a very beautiful site of the tower. You can see the inclination of the tower, the curving of the tower, and the belfry, the topping of the tower with the bells. There are 7 bells on the top, and the biggest one is more or less 36 quintals, so more or less 2 cars. So they were stopped, and they didn't work because the vibration of the sound could create some problem to the stability of the tower. Now, last stop, the walls of Pisa. The walls of Pisa are something amazing. A lot of people used to walk on the walls. You can see also young people, they enjoy the walls of Pisa, and it's nowadays we can walk for about 2 kilometers on the walls of Pisa, but when they were built in the second half of the 12th century, they were more or less 6 kilometers, and they surrounded the city, the Middle Ages city of Pisa. Walking on the walls is really beautiful because you can see something that you really cannot visit. For example, this is, let's go just a little over there. On this side, we can see the Jewish graveyard. This is, you see that the walls are really changing their direction, making an angle. Well, this part of soil, this part of land was inside the walls. But when the Medici conquered Pisa, they also changed the route of the walls. They gave to the Jewish community a piece of land in order to establish their own cemetery. So let's go just a little more on, you can see the building of the graveyard. And the graveyard, you can see there is a pretty new roof because the original one was destroyed by a bomb during the Second World War. And well, the problem was not the roof, but the fire that followed the bomb, the shelling, because the fire spoiled the fresco that were inside the graveyard. The graveyard was completely decorated by frescoes and graves, and the soil is said that was coming from Jerusalem, because by tradition, this kind of soil changed the corpse into ashes in 48 hours. So this was said by the tradition. And the graveyard was built at the end of the 13th century. It was the last building to be built in the square. So let's go further and further again. Along the walls, you see that they surround completely the square. Let's go here. And this is also a very interesting part of the walls, because we can see the Tower of Pisa here. We can see the cathedral. Well, in the cathedral is also very important, because inside the cathedral is kept the shrine dedicated to San Ranieri. San Ranieri is the patron saint of Pisa, and if you are planning to visit Pisa, well, you can plan your trip here in June. And on the 16th and 17th June, there is a very big celebration dedicated to San Ranieri, that's a patron of Pisa. And the city is decorated with candles. At night, the candles are lighted up. So coming to changing the city into well, into something really different. A lot of candles, thousands of candles all around the city, all along the river Arno. So it's really a celebration, a very amazing celebration. And it's called Luminara. Luminara because lume is light. Then we can see the baptistry again. These buildings are the buildings of the Opera Primaziale di Pisa. Sometimes you see on some coat of arms the word OPA, O-P-A. It means Opera Primaziale Edificandi. That's to say the group of people chosen by the church to direct the works of the piazza, of course, of the building. Take a look at this strange machine. It has been very useful with another one like this one. They were two, and they were the anchor blocks. So in the upper part, there were the cables getting to the tower, surrounding the tower, getting around the tower, and they were fixed to the second machine, the anchor block, and they should have kept the tower in case of collapse. But well, it has been not a luck. It has been something good from the works of the engineers, because they never entered in action. Well, this is the last stop of our tour, but let's go back to this main site, because isn't it a miracle? The hospital, the cathedral, the baptistry, the graveyard, and the bell tower. The bell tower that, well, if you have been in Europe, you see usually bell towers are square and in a square shape, and usually attached to the churches. But this one, well, probably the architect Bonanno was influenced by the Arabs that lived here, and so it was made as a minaret, we can say, as a minaret that is used to be built by the Muslim. So they didn't care about differences, and that has been the richness of the city of Pisa. Well, we finished the tour here from the modern, the contemporary Kettering till the Middle Ages wonder, one of the seven wonders of the world, a UNESCO heritage location. So I really hope you enjoyed the tour. A very different kind of tour with this engine that's very unusual for us as a guide, but it's really nice. I think I hope you enjoyed really, and that you will bring Pisa in your heart and plan a trip here to visit Pisa, Tuscany, and to meet the people from Pisa. Tuscany too. Here we are.